So hi again. I hope you had a little rest, and actually it was really little rest because we're a little bit late, but never mind. So the next 3 talks I hope will be really amazing, and after that we will have a Q&A session as usual. And I remind you that my name is Anna. I am your host for the next block. And if you have any technical issues or you have any questions, so please let me know about them in chat. And of course, I'm waiting for your comments and questions. That's why I want to remind you that you can take your chance to win a ticket for an upcoming Geekle event of choice. So write your questions to our speakers in the comments, and then end of summit, we will randomly choose 5 lucky winners to provide with a ticket. And of course, don't forget to use our hashtag #questionforticket. So be active and let luck be on your side. So now we will hear a talk from Paloma Aguiar. So the talk title is Building a Smart Manufacturing Architecture. So Paloma is cloud architecture in Oracle. So hello, Paloma. Hi, how are you today?
Hi, hello. I'm very fine. So happy for attending this event. So thanks a lot.
So do you have presentation that I should help you to share? Yeah.
Yeah, I'd like to share my screen. Let's see if you can see my screen now.
Yes, I can
Yeah.
see.
Okay, so let's put
But there are like still no presentation there.
Yeah, so can you see now?
Yeah.
Right?
Here it is. So great. I wish you and our audience have a great time together. So we'll be back in a half an hour.
Okay. So hello everyone. So I'm really glad to be part of this event, for being invited. So today I'll cover the talk about how to build smart manufacturing using IoT. So thinking about the architecture, how we can use IoT to bring smart manufacturing. So before starting, I would like to introduce myself. So my name is Paloma, and I'm originally from Brazil, from São Paulo. I study computer science and I completed an MBA in information technology in the University of São Paulo as well. And I work during my career, I work almost 10 years for Ericsson. So during this time, I was able to work with different countries, with different cultures. It was really interesting. So I was able to travel a lot. So I travel mainly in Latin America. So I visit Colombia, Uruguay, different countries in Latin America. Currently, I'm working as a cloud architect for Oracle. So I'm working for Oracle almost 7 years. So, but now I'm based in Malaga, in Spain. So I worked almost 6 years in Brazil. And during this time, most of this time, I was always working with data management solutions. So working as an architect, working as a pre-sales, and helping customers to design a better solution for them. So I also have a few certifications So mainly about database, about Oracle solutions, but the last one that I got is the OCI Architect Professional. So I really recommend, if you are interested to work as an architect, you can try to follow a track about this kind of cloud providers that can give you some information. So it's really a very nice start point if you are interested to become a cloud architect as well. So let's start. Since that we are working with technology, we know about how many times we listen different words and how the technology change all the time. So we are working with a topic and suddenly we realize there are a new topic, and maybe these topics are, most of the time these topics are correlated. So there are very different things, and what is very interesting that you can also have some knowledge in a technology that you can like more. And for me, IoT is one of the technologies that I really like, that I really think that can be useful for different kind of people, for different approaches for company, for students. So I'm really passionate for this kind of technology. So, but what is in fact an IoT device? So when we are talking about IoT, what is an IoT device? So let's start with the basics. So an IoT device is an electronic device that you can send information and also you can receive some information and you can communicate with a network. So I can use Bluetooth, I can use internet, and I can send some data. So I can ingest some data in some platform. And usually this IoT device, it combines the hardware and the software that has the intelligence about the specific action that this sensor, that this IoT is prepared for. And it can communicate with different environments. It can communicate with an edge device, or it can communicate with a cloud platform and can be after user for cloud applications that I can consume this kind of information. And when we are talking about IoT devices, it's important to understand. So we can have different IoT device, and you can use this IoT device for different kind of usage. So from this slide, maybe I think that one that can be really popular and can bring for you some experience is the Raspberry Pi sensor, that it's like a small computer that you have in a size of a credit card. And this is only board that you can connect with your monitor, with a TV, and you can perform operations like it was a computer. So it's really interesting. This solution was developed with the purpose to help students from computer science around the world has the capability to explore more the technology. So they can have a PC, and they can do some actions. So it's quite interesting. I recommend, if you are interested, to start with IoT, if you try to go to YouTube and use and try to find for information about Raspberry Pi, you can see a lot of information about how handling this information using Python at the end. So it's quite interesting. But for the session, I'm focused on talking about smart manufacturing. So since I work for Oracle and I have been in touch with some IoT providers, and here I am just sharing some names like Huawei, Siemens, that they have some kind of IoT device that can help you to use this in a smart manufacturing industry. So imagining, for instance, for Huawei, if for Siemens, I know that they have also an IoT device that you can use to create, to use digital twins, that you can have an image for instance, for your physical device, and you can have this information like digital, and you can do different things. You can modernize your device, you can test how it could work if he could have a different port in a different way. So you can really explore different ways to use this kind of technology. And I was almost forgetting, there is a very nice case that here I'm based in Malaga. Malaga is a city in the south of Spain, so we have a lot of beaches here. And during the COVID, during the pandemic, it was quite interesting. They have a kind of sensor that was combined with a camera, and they could take pictures from the beach. And these pictures were being processed in a heat map way that could visualize, if the people were respecting or not the rules for the COVID. So they could act immediately. If they know that there are too many people in a specific area, they could make decisions and take actions immediately. So you also can combine this. And it's very common also for smart manufacturing has this kind of cameras accoupled for a safe environment. So there are different things that you can do with IoT. Probably you already is using, for instance, I am using a smart watch. So you can see here, it's a Garmin watch. So I can use the information from my bike and send some data for the Garmin APIs, and I can process this information. I can also combine this with some platforms like Strava, and I can put the data inside my smartwatch. So I can take the data from Strava and I can say, look, I want to follow this route again, and I can use this kind of information. So your IoT device can be active or can be also passive. So it's bidirectional. So it's quite interesting. We can explore a lot of things using IoT. And when we are talking about the data that we have in IoT, so usually the data that it's processed by IoT, they are a small device, so they process like a single record with just a small size, but they have a lot of records. So I have a single record for a specific event, but I can have millions and millions of records. So when we are thinking about how I can handle this data, because at the end, what I need to be careful, it's how I handle this data. So it's very common when we are talking about IoT and thinking also about cloud, because we can bring some capabilities, for instance, about serverless solutions that I don't need to take care about the final size. So I can grow based on my need. So this is really interesting, but it's also important if I'm thinking about that I generate a lot of single records with millions of records being generated all the time. And I need to think about where I will start this. I'm going to start in the cloud, or probably I will go for a solution in a cloud, but I need to have some solution in my on-premise environment, in my infrastructure, so in my data center. But what is the best solution? So when we are creating an architecture, I need to think about this, what I need. So if I'm doing a lot of writes, like I mentioned here in the slide, so the IoT generate a lot of writing. So I needed to take care about the I/O that I have in my storage. So I needed to look for a storage, for a data store that can process this amount of data in a performance, with a good performance. So just sharing, usually when we are talking about IoT, we go with thinking about database. We go with a NoSQL database because we don't need to have too many relationship between this data. So it's very common when we are talking about using IoT, we go with a solution for writing and a NoSQL database. So, and thinking about this come a lot of challenges. So this huge data volume that can generate all the time, and you need to think, and also it's not just one sensor, two sensor. We are talking about thousands. We are talking about a very big amount of sensor. If you are thinking about a manufacturing industry, so we can have different floors and we can have different equipment. And sometimes I want to measure the temperature. So sometimes I wanted to measure it in a chemical industry. Maybe I wanted to measure the pressure for the water, for instance. So we need to handle all this information. So we have different data sources. So I have different kind of sensors that can talk different protocols. So usually one of the more common protocol for IoT is MQTT, but also I can use HTTP, I can use JSON, I can use binary. So there are different kind of protocols that the sensors can communicate. So it's important to consider this kind of thing when we are designing a solution. And thinking about the retention policies, imagining that I'm generating a lot of information, and as I mentioned before, we have different buzzwords nowadays, like for instance, big data. So I have a lot of data, but what I do with this amount of data? So it is important to know what are we handle. So I needed to have a policy for purging data as well. So I used this information, and if at time this information was not relevant, I can purge this data. So it is important to keep your environment running on with performance, that you won't be bring too much cost at the end for your solution as well, having information that at the end you are not using. So because of that, it's important to know when you going to analyze this information, this data in a real time. So, okay, if I need to take actions immediately, like I mentioned about the COVID here in Malaga, so I need to design a solution that can be really fast, and I can process this information in a very smart way that I can take actions, and my business at the end can have best decisions, like a data-driven company. So I have the data and I need to act. So create all of these with a solution that can be always on, that can be performatic. So there are a lot of challenges, but it's important to consider this kind of thing. Because, for instance, for the manufacturing industry, I'm sharing here just some information that I got from the source that I mentioned here. So how many companies, how many manufacturing industries has been faced unplanned downtime in the last 3 years? It's a very big number. If you think it's almost 100. So it is important. If I can avoid this, how this could help me at the end. So if I could have avoided this, probably I could save a lot of money. So invest in technology. Sometimes the time will reflect for you and you pay. your solution. So, and also what I mentioned about the amount of data that you can collect and how much data you are in fact analyzing. So there are too many things. I was working with a partner here for our EMEA that I'm usually working, and they have a very nice solution for the smart manufacturing. They have a solution that at the end they have different sensors that send the information for a smartwatch for the operators in the manufacturing, and they can act immediately. So they can send information if the temperature from a specific machine is getting too high, and so this operator can have some action. They can also have this information in different fabrics, not just in a place. So they have fabrics in Germany, they have fabrics in Switzerland, so they can have this information consolidated. So it's really interesting what we can do. And when we are talking about this enterprise model for manufacturing, so we have the assets, we have the factories, we have the suppliers, we have different business applications that support my business. So I can have CRM, I can have ERP, and I can engage my users or my operators with different technology like chatbot, mobile, or web. But when we are thinking about IoT and using more intelligence, I can have more visibility for my business, and this can really change. We can bring much more capabilities for my solution. So if I can use IoT, if I can use machine learning using artificial intelligence, if I can use blockchain, so I can guarantee that my information is completely accurate. So all of this can bring at the end a lot of value for your business. So using IoT, using technology is every day become more important to the companies and to create a smart business. So, and when working as an architect, as I have seen in the previous presentation for the previous speakers, so usually when we are an architect, we have like a reference model. So if I'm looking for creating an IoT architecture, so what is the reference model? How I can see that how I can guarantee that I'm follow a very good way, a very good approach. So for instance, Cisco has this kind of reference model for creating. So it's like different steps or different layers that you need to follow. This can be parallel for each action, but it's important to consider. So for instance, at first, we need to have the information about and make decisions about which kind of sensor that I'm using, which kind of device, if I'm going to use a camera with my solution as well. So I need to evaluate what is what I want to achieve and how I can design this, which solution can help me on that. So how I communicate with this. So how is the connectivity? So I need to have a gateway that I can process this information for a cloud provider, that I can have a better security implemented on it. Or I want to have an edge device in my infrastructure, in my data center, because I have low latency or I have a big latency, with my cloud provider, and I don't want to have any problem, and I need to take action immediately. And I will send this information after in a streaming way that I can process in a synchro, not in a synchro mode. So we can also measure this kind of thing. And what I mentioned before about the storage, how I will store this information. So it's a lot of data. I needed to know how we process, how we store this information, how we do the aggregation of all of this information. I'm having information from different devices and a lot of information. So how I integrate and how I report this for my business. So this will come with the dashboards. So I have a lot of visualizations. What is the best visualization for this kind of thing? So it is important also think if you look for data visualization tools, there are a lot of visualizations that are prepared for manufacturing industry. So I can follow. So I know that this is a very good way. It's an easy way to show a heat map, to show about the amount of failures in a production environment. And also it is important involve the people, the government. So how this process are designed inside the company. And not just Cisco, but we know Gartner that works with different kinds of reference model. And here it's also a reference model for working with IoT. So here we have a little bit more of information for all these steps. So we have the sensors, we have the gateways, like I mentioned, we can have digital twins, like I mentioned. I wanted to modernize my solution, and I want to have an idea about how this physical device could become if I do some change. Imagine if for a car industry that I can move some specific pieces of my car and I can simulate at the end how the solution could be. This can be really helpful for them. So the communication layer, like what kind of protocol this device are talking, how, because I needed to process this information. So the information layer, like I mentioned about the data, if I'm going to ingest the data in a NoSQL database, if I'm going to ingest this data in a Hadoop file system. So there are very different approaches that we can follow, but it is important to consider which one can really reach what we need so that I can achieve my purpose at the end. So in the function layer also, I can use some algorithms for machine learning. So usually when we are talking about the data visualization tools and the data layer, we can have this integration, and I can use machine learning algorithms to make predictions for my last experience in the past. So they can learn for your past, and they can suggest you some actions to avoid a failure again, or even to predict that some failure can happen. And the governance. So I need to keep my team updated about how to use this kind of information. And going to just a bit deep diving in the solution here, it's Oracle. I work for Oracle, and Oracle has a solution for IoT for manufacturing industry that it's completely prepared. So you don't need to take care about this. And we know that other cloud providers also has this kind of solution. But what is behind? I just shared this slide just to have an idea about what it's behind. So what I mentioned, we have the IoT device. Here we are mentioned 3, but imagine a lot, millions of IoT device. And I have a gateway that it is important because it provides like a hub for your device to connect security with security in your cloud provider. And I can send this in a way that it can process this information. So we have here, usually it's very common using Kafka. So I can process these messages in a near real time, and I can send this information in a streaming way for different platforms like Spark, like ATFS, Hadoop, Big Data, and I can process this in a batch way, or I can send this in near real time, and I can provide this information for my business. So there are different things. I can have different APIs connected for my environment as well. So like I mentioned, I can integrate some services. So I have the smartwatch for Garmin, and I can use so the API gateways from Garmin to take the information from Strava, that's another provider. So we can also enrich our solution with this kind of technology. And here, just to have a big overview about the capabilities that we can reach. So we have the protocols, like I mentioned here, that it's very common for IoT, the sensors, and for recommendations, for detections, recommendations, and predictions. How we do this? So we have this mechanism about using digital twins. I can have mechanism with sensors to evaluate to monitor my tasks in progress. So I want to monitor my fabric, and I can use the mechanism of machine learning to recommend optimizations in an accurate way. So I can avoid failures, and I can do comparative analytics, and I can provide this in dashboards for the business. So, and I can have like inventory, for instance, for the assets. It is important to know the assets in a fabric. It's very common that we are talking about very big space. So I can control better, and I can avoid losing time or even lose pieces. So I can have a better asset monitoring for my company. And the infrastructure that is behind this, so like I mentioned, we have the database, we have the big data. It's very important, the security for IoT, because we are rendering data. And when we are talking about cloud, we also come with the encryption. So we know that there is no cloud without encryption. So this is one of the points that I think that it's important when we are thinking about IoT with cloud. No matter with what is the provider, but it is important. So also we can generate the dashboards. We can use apps in mobile, with a smartphone, with a smartwatch. We can use augmented reality. So imagine that I wanted to see how this equipment could be in a specific place. So I can generate this kind of thing, and I can simulate an equipment in a specific place. So it's also very interesting. And here I'm sharing just some screens from that I got from the Oracle solution, but it's very common for IoT applications for manufacturing. So I have I need to connect, I need to analyze, I need to predict, and I need to act. But which kind of application we have for this kind? So I can have asset monitoring, I can have a production, I can have fleet monitoring, I can have connected work. So I want to guarantee that my operators are working in a safe environment. I can have the service monitoring. So what this means, that I can monitoring my work, and I can monitoring different places. It's very common for IoT solutions for manufacturing, using a lot of graphics as well. So imagining that I have a fabric that it's in a different state. So I wanted to monitor the services in different fabrics. And maybe I can learn from different fabrics that one fabric it's working better because they are using a different temperature or a different way of dealing with a solution, so I can improve. And also I can have more visibility about my business. So this is really interesting. So like I mentioned about the production monitoring, imagining that I'm doing some detections, and I can connect and analyze that I'm having some anomaly. So I can act in a proactive way and avoid that this equipment can be down. And I can do a lot of recommendations as well. So there are different things that you can implement to use IoT to improve your business. So after talking about all of this experience that I shared with you here, so for me, what is the highlight ideas for architecting with IoT? So one of the things that it's very important when we are thinking about IoT, it's about data driven. So I have a lot of information. I have information from different devices. I have information coming like explosion. So how I can handle this and how this is important for me to handle this information to become to make my company become more data driven, because we know that we shouldn't have to act like by feeling way. So maybe I should take actions and decisions based in data. So this is important. So I can really act in and I can really prevent that my company goes with a wrong decision. So it is important. I can use this information, all of this that I collect in a smart way, so I can explore this data. So this is really important. So when we are talking about data driven, because of this, we say that using some serverless solution, it's important because I can have a lot of data there, I can grow, I can scale up, and when I need, and I can process this information by an accurate way. So this is really important. So using also some mechanisms, so it's very common when we are talking about a solution for data, we have some visualization combined. So it is important to use these visualization tools, this form of process this data, and using the algorithm that we have for machine learning to improve my decisions. So I can create predictive analysis for different kind of sensors or for different kind of need. So I can avoid have any trouble in my environment. And this is interesting. I mentioned it. It's important also, even before, look for what kind of visualization I will need, what kind of map could be interesting for me, like using for a map for the fabric. I can import this map from my fabric and I can act immediately, having some visualization in near real time. So modernize the solution with lower costs. Like I mentioned before, the Raspberry Pi sensor, it's cheap. Sometimes we can start with something small and analyze how this can be really important and can help my company. So you can start using. I was seeing the price for some Raspberries sensors. It can start like $5. Of course, it's for the small thing, but I can have so many idea and for who is starting. So maybe you can have some inputs. And also another important point, like I mentioned in the slide, we have a lot of things behind of the solution. So it is important to know, this is another point when we are talking about cloud. I can connect and I can integrate different services. I can use infrastructure, I can use platform, I can use integration, I can use events, I can use functions, I can combine these things by a faster way and reduce the risks about integrate things that cannot talk with each other. So it is important to also know how all of these will be connected. And one of the things that we know, it's the best time to market. So how much fast I can act, I can have some competitive advantage. So real time for making decisions, it's really important. So I can improve my business, I can accelerate my solution for having a best approach in the market. So this is really, really important. So this is the end of my presentation. So thanks a lot for coming for my session. Feel free to reach me on LinkedIn. I'd be glad to expand my network and share some knowledge if something that I explained here was not clear. So feel free to reach me and I'll be really, really glad to share.
Paloma, thank you for your amazing talk. So we received like comment that it was really amazing and your presentation was perfect. So firstly, I remind our audience that we will see Paloma a little bit later on our Q&A session, so we will have opportunity to discuss every question we have. And secondly, I would like to remind that recording of Paloma's talk and other speakers' talks will be available soon on our new Geekle educational platform, link to which I'm like sharing right now. So Paloma, see you really soon.
See you. Bye-bye.
Bye-bye. So personally, I really enjoyed the talk, and I hope you made some questions, some notes. And now it's time to hear a talk planning a cloud migration for a complex SaaS solution from Philipp Pickel, who is a principal DevOps engineer in Horizon Alpha. So hope you'll enjoy this talk, and you will be able to see Philipp live in our Q&A session. So please write down your questions so in our comments or somewhere like for yourself.
Hello, everyone. I hope you've enjoyed this conference as much as I did so far. I'm really happy to be here and speak to you about planning a cloud migration for a complex SaaS solution. First, a few words about myself. Hi, I'm Philipp. I did a master's degree in information systems. I founded my first software company back in 2012. I'm a certified AWS SysOps administrator. And at work, I plan and implement cloud architectures and do cloud migrations. So far, I've worked with the main three cloud providers, AWS, Microsoft Azure, and Google Cloud. I work at Horizon Alpha. We are a company based in Munich, Germany. We're about 25 people, and we mainly focus on React web apps and React Native mobile apps. For those apps, we use backends in the cloud environment because this provides its easy maintenance, high availability, and easy scalability. Besides this consultancy, we also have two own products, Team Sports and Team Fit. You will hear about Team Sports later on because it's our real-world example for planning a cloud migration. But first of all, why does one do a cloud migration? Normally, the main driver are cost savings, but cost savings can come from different things. So first of all, there's scalability and elasticity. So with good scalability, you don't have always to have enough compute power for your peak load, but can scale it accordingly to usage. The same goes for elasticity, but in a much shorter time frame. Another advantage of many cloud environments is that you can have easier deployments because normally those cloud services are heavily integrated and make a deployment easier. One of the main points is always that you can have really easy maintenance. If you don't want to do any OS patches or things like that, you could go for serverless services or have your app environment already provided. Another interesting point of cloud environments is the easy high availability you can achieve. So there are services where you don't have to do any further configuration and have high availability already. This can also save you costs if you have service level agreements with your customers. So those sub-objectives of cost savings might compete with each other. For example, if you go for the easy maintenance, you normally pay more per compute cycle if you have things like serverless or a provided application environment than if you would use a virtual machine. But it might be worth the cost per CPU cycle to don't have to do the maintenance. So you always have to think about those objectives when you want to do a cloud migration. So what are the steps I normally do when I plan a cloud migration? So of course, the first step is the current state analysis. So you have to describe what is the current state of the application and especially the architecture. What are the pain points of this architecture or the setup? So if there weren't any pain points, you wouldn't consider moving it to the cloud. And you should also have a look at the development and deployment process, because this process must also be part of your cloud migration and must be set up for the cloud then. So after you did your analysis, I know what the current architecture looks like, and especially what the pain points are. You can start to make your perfect cloud architecture. I put perfect into quotes because, it might be under heavy discussion what is really the perfect architecture. So don't think anymore about the current application, but think of it as a greenfield project. You just want to start, and what would you do for your architecture in the cloud then? So for this architecture, you would also have to think about your objectives you want to achieve with this architecture. And in the best case, it relieves the pain points of the current application. So after you've thought of this perfect architecture, you normally have to adapt it for the existing projects, because normally already existing application comes with some limitations. And so if you don't want to throw away every line of code and throw away your whole project, you normally have to adapt your perfect cloud architecture to the existing project. So this adapt step is really important, but don't let too much limitations be there. So if you have adapted your perfect architecture to a target architecture for your existing project, then you can plan smaller steps for this cloud migration. I would advise to always make small iterative steps. So move one part after another to the cloud and to see how it works out, and not try to move the whole project at once to the cloud. So for each of these smaller steps, you have described your target architecture after the step, and then of course you have to do this. So only plan the next step exactly, and do only a more broad planning on the steps after that, because you will refine them in the process. So let's move on to our real world example. As I said, we have at our company this product, Team Sports. The development for this started in 2011, and it's a content management system for sport club websites. As most content management systems, you have a front end where you can show text, pictures, and so on. And you have a back end where you can put up all this content. So And this content management system is specialized for sport club websites. So you have things like you can show your teams, you can write articles on your last or upcoming matches and things like that. So to get to a more technical perspective, this is written in PHP and has quite a heavyweight framework used, which is called Cake PHP. So to date, about 160 tenants are there, and it's in a single tenant fashion build. So we also do have a self-service website generation, and one of the pain points of this application is that after a website is generated and then the customer decides he wants to use this product further, we have to move him from one to the next server. So to give you a bit of perspective over all these tenants, we have normally, I must say, because in Corona times it's not like that, but normally we have over 1 million unique users per month and over 50 million page impressions per month. So what's the current state of this application? As I already said, it's single tenant. This means that each tenant has a single instance with a database, and you have to deploy each update to this tenant. All those tenants are on self-managed servers. So normally there's more than one tenant on each server. So we have to maintain a couple of servers to run this product. One of the already done things is that we have a continuous delivery. It's done via deploy HQ, and this deploys the PHP files on click to the instances of our customers. As I already said, we use Cake PHP, which is a really heavyweight framework, and it uses an MVC pattern. So you always render the whole site or deliver it to the user. It also does the routing for us, and it also does the routing and a bit more things. So as a side note, we currently don't have redundancy because in this market, high availability isn't that important. So after we've now looked at the current state, we also have to think of our goals or objectives of the cloud migration. As I said, we have to maintain a lot of service for this product, and that's the main goal, to reduce this effort and get rid of it. Another thing is that we want to have a one-click deployment. We have some continuous integration, but we want to further advance that. Also, elasticity and scalability would be really nice to have, because as you can see on the left, the usage heavily depends on the day of the week and also on the month of the year. So normally in the summer and winter month, there isn't that much sports, so there are less visitors to our sites. So, and as a last objective, I put in high availability. It's not that important, but it would be nice to have. So let's jump into the perfect architecture for this application. So how would the application itself look like? I would definitely use a multi-tenant approach and probably make it a single page application, for example, with React or AngularJS, Vue.js, something like that. And then you could have something like Node.js in the back end, because there isn't any really heavy computing, but mostly only querying the database and getting the right data. So how would I set up this in the cloud? So in the first, I would put an API gateway, because the Amazon API gateway could nicely integrate with Amazon Cognito for authentication and authorization. And I must say, I always used here the AWS services, but there are similar services for Microsoft Azure and Google Cloud, so you could also put this up there. But I choose to use AWS because I'm the most familiar with and know how to use those services. So as I said, I would use an Amazon API gateway integrated with Amazon Cognito for authentication and authorization. And what it also brings is intelligent routing. So you could decide, oh, one request has to go to S3 because it needs to load some static resources like the JavaScript for the single page application or some pictures or things like that. And what it also can do is caching. So you don't have to put an additional layer of caching there. You can already do this with this Amazon API gateway. And if you need data from your database, you could use AWS Lambda to do those queries to somehow transition your data and make it into the form you need it in the front end. So AWS would be the compute resource, and as a database, I would use Amazon Aurora, probably serverless, because this Aurora serverless gives you the ability to have also scalability and some elasticity for your database, which is really nice. And with this setup, we already have reached, or we would reach our main goal to have almost zero maintenance effort and also have this scalability and elasticity, as well as high availability without any further configuration. So for the deployment part, which should be a one-click deployment, I would use Code Build. It nicely integrates with Lambda, and you can use the serverless application model there. And because of using Code Build, it would be the easiest to use AWS Code Commit to host your code. So, but we don't have a greenfield project here, so we have to adapt this architecture to the existing application. So what would be this adapted architecture look like? So I would still go for a transition to a multi-tenancy because this makes life really easier. The thing that would have changed is there's no Amazon Cognito anymore there, because the current application already has some way of authentication, authorization done via queries to the database. And I would keep this authentication, authorization, and don't move this to AWS Cognito, because yeah, this would be quite hard to do. Also, in the backend for the Lambda functions, I wouldn't use Node.js, but use the existing business logic written in PHP. Even though if I would get rid of the framework or most parts of the framework, you could still use some of the or most of the business logic, and so it would be PHP, which is running on Lambda. The rest almost stayed the same. One thing is, since our code is on GitHub, we would use GitHub to integrate with Code Build and as a provider for our code repository. So now we have our target architecture for the application, and now we need to find steps we can take to get to this adapted architecture for our application. So in the first step, I would do the transition to multi-tenancy. And as you can see, I switched Lambda for Elastic Beanstalk. Why Elastic Beanstalk? Elastic Beanstalk provides you an environment for your application. So you also don't have to maintain the OS, and you also don't have, for example, install the right PHP version and things like that. This is all done by the cloud provider. So this would give us the advantage that we don't have that we have heavily reduced our maintenance effort, but can keep most of our current application, because we can run the whole cake PHP in this environment. So this would be a nice first step. So we already moved the application then to the cloud, but don't have to rewrite that much. And how would the second step look like? In a second step, this is a bit more complex than the first step, because we would start to shift the application to a single page application part by part. So that's why in this diagram, there's not only Lambda or Elastic Beanstalk, but both. The thing is, you could still have the old application or parts of the old application running in Elastic Beanstalk, and concurrently developing your single page application in AWS Lambda. And as soon as one part is finished there, you can switch over the routing so it goes to AWS Lambda, and using the single page application instead of the old one. As you can see, already shown in the diagram, this setup is a bit more complex than it was before, because you have to configure Elastic Beanstalk as well as Lambda, and you also have to deploy it to both of those services. But as I said, you should always do small steps, and that's the perfect example where you can do those small steps, because you don't have to rewrite the application as a single page application, but can do this always for small parts, then release them and do the next small part. And that's why I decided to go in the second step for this cloud architecture. So after everything has been shifted from the old application to the single page application backed up by AWS Lambda, then we would reach our adapted architecture we defined before, and the goal of our cloud migration. So here, as you can see again in the diagram, that we have this adapted cloud architecture with API gateway, S3, Lambda, the serverless Aurora, code build, and GitHub. And then we also have completed all of our objectives. So we have heavily reduced the maintenance effort. You could even say that there isn't any real maintenance effort after you have configured all of those services correctly. Also, we have this one-click deployment by code build. After setting up one of the build pipelines correctly, then everything would be deployed to Lambda as we want that. And those compute resources and also the database give us the elasticity and scalability we wanted to achieve. And as more or less a side product, we also got high availability, because all those services are maintained by AWS, and only if the whole region would go down, those services would have an outage. So after we finished our cloud migration at this real world example, what are the key takeaways from this presentation? So first of all, you must have a good understanding of the current state of your application, but you should always be aware what are your main goals and objectives of this cloud migration, because this can heavily influence which are the right services for you. Because if you want to have the minimum of cost per CPU cycle, you would probably go for virtual machines and things like that. If you want to reduce your maintenance to almost zero, then you would go for serverless and things like that. And of course, there are steps in between. So I would always advise not to think from this current state, but to pretend that you would have a greenfield project at first and think of the perfect architecture for this greenfield project. So you only take the business needs from your current application, but don't think of the limitation the current architecture of the application brings. Because so you can think more freely and maybe decide that the advantage of the perfect architecture or part of the perfect architecture is worth much more than the state of the current application, and maybe then you could decide to throw away parts of the current application and go for the perfect architecture, part of the perfect architecture, instead of thinking always, oh, you have this limitation and you must comply to them. But in most cases, I guess that you can't do your perfect architecture, because you would have to throw away most of your application, and the current application already has proven to have worth for the customer, and also has normally really much intelligence within it. So you don't want to throw away this knowledge which is already in this code. So you have to adapt your perfect architecture, and that's always the trade-off by changing the existing application or changing the perfect architecture. And I guess that's one of the hardest steps, which is the correct trade-off to reach your objectives. And another thing I would always advise is that you should do your cloud migration in small iterative steps, because there's a huge risk if you want to do it all in one big step, that something doesn't work out as planned, or the transition is almost impossible to do. So plan small steps and learn with those small steps, and by that you have a high chance of your cloud migration to succeed. And I hope after that presentation you have a better understanding how to plan cloud migration, and you will have success with the next cloud migration you do. So I want to say thank you for your attention, and hopefully we will see each other at the Q&A. Thank you.
Yeah, now I'm not muted perfectly, so it was definitely worth seeing, isn't it? So we definitely see Philipp in in half an hour, on the Q&A session. He's already in the waiting room. Now we are ready to hear last talk in this block before our Q&A session. It will be a John Savill with topic building resilient service in Azure. So don't waste our time and start the session right now. So have a great time. And please be active in the chat. So ask any questions you want to discuss on the Q&A session. So it's really important for us to see you being pleased and interested in our summit.
Hey everyone, welcome to this session on building resilient services in Azure. My name is John Savill. I've been working with Microsoft technologies for over 25 years. I recently published my 9th book. This was all about architecting Azure services. I have a large number of courses on Pluralsight. I have a very, very active YouTube channel where I have playlists around Azure Masterclass with like 20 hours of content. I do a weekly update. I have lots and lots of deep dives. So a lot of just free content, no advertising available there. Outside of computers, I enjoy fitness training. I do a lot of Ironman events, hopefully going to Hawaii this year. Now, for this course, I really want to talk about, well, do I even need to worry? It's the cloud. Hey, I deploy things to the cloud. I'm good to go. So is that true? Spoiler alert, no. Then I want to try and think about, well, what are we trying to be resilient against? What are the types of failures we may actually encounter? I think about different blast radiuses. I can think about what a disk could fail, a node could fail, a rack could fail, a data center could fail, a communications line could be cut. There could be a natural disaster. They each have different levels of impact. So what do I think about and how can I build resilient services against them? And then some special considerations to when I use multiple regions. So first, do I even need to worry about this? Again, you think about, I'm going to the cloud is indestructible, I'm good. And sometimes you'll hear, and I've seen people with t-shirts, and it will say there's no such thing as the cloud, it's just someone else's computer. And there's a small element of truth to that. Now, obviously, the cloud is more than just capacity, which will be someone else's computer. There's services, there's management, there's a whole rich tapestry of things around it. But fundamentally, there's still physical constructs that house the resources, servers in racks in buildings with lines of power, lines of communication. So do I need to worry? Well, it depends, but realistically, yes. Azure has this whole shared responsibility model. I can think about what am I responsible for as the customer? What is Microsoft responsible for as the hosting with Azure? We hear about different types of service, infrastructure as a service, platform as a service, software as a service. Now, if it's software as a service, if it's Office 365, if it's Dynamics 365, it's not really my responsibility. There's really nothing I can do to impact the availability of my service. That's down for the provider. But if it's infrastructure as a service, i.e. a VM in the cloud, if it's platform as a service, for pretty much all of those, I still have to consider availability. Often with those services, I'm still deploying to maybe a certain region. I'm picking certain replication or resiliency options. Now, things like Azure Active Directory, once again, that's a managed service. I don't have much control over that availability. There are SLAs around that. That's really Microsoft's job. But even within Azure AD, there are things I can do to make things more resilient. Managed identities, for example, for my applications are more resilient against hiccups in Azure AD. Having longer lived tokens, but using things like continuous access evaluation can again make me resilient if there was some kind of Azure AD hiccup. But what am I actually trying to be resilient against? Now, we always think about, well, there's the application, there's an operating system. Whether this is infrastructure as a service, i.e. a VM, whether it's a PaaS, there's still an underlying OS there. There's still your application and they can fail. So I want resiliency against the failure of my app against the operating system. Physical boxes, they're still servers. Now, there's great resiliency built into the servers, redundant power, networking, but nodes still have failures. Racks have power supply units. They have network switches. Things can fail. I can think about an entire data center can fail. And once again, we have to think about, well, the data center, it has power and they have generators, they have resiliency, but ultimately things can fail. Network communications could fail. And failure doesn't necessarily mean a physical problem. There's a whole set of infrastructure and software that runs Azure. So if they deploy a software update, well, what if that knocks out a portion of Azure because there was a problem with that? We can have region level outages. Now, obviously, they're very rare, but it could happen. There could be some kind of natural disaster that knocks out an entire region. And when we think about what do we want to be resilient against, all of these things to this point have been a failure of some kind. But realize there's also planned maintenance. Within my app, I want to roll out a new version. Well, I don't want to take it down. Maybe I have a maintenance window. Maybe I don't. So maybe I need kind of maybe blue, green, or I'm doing rings of deployment or canary. There's different methods, but I need multiple instances to be able to roll those out and a means to balance the traffic coming in. Azure itself, they have a whole set of workaround. Don't have to reboot the box to even patch the kernel. Things like preserving host update to update the box without actually having to shut down the VMs, just pause them in memory for a few seconds. But there is that planned maintenance. And we always have to consider there's a compute side, i.e. doing work, and then there's storage, our state. And I have to think about both elements for resiliency. Now, maybe I have something that's pure cattle, it has no state. Maybe it's ephemeral storage on the host itself. But when I think about resiliency, often I have to consider the state is actually more important. The compute I can recreate pretty quickly. I need to be able to get the state back, be it in a database or on a disk or something else. And I have to understand what is my resiliency requirement. How much data can I lose? How much time do I have to get up and running again? What things does it depend on? So I have to know my service to really be able to work out what I need to do and what I need to be resilient against. Now, when I really think about what is Azure, well, Azure's capacity. Capacity in terms of compute, in terms of storage, in terms of network, in terms of specialized things like GPUs, but it's capacity. And then, of course, that capacity has to be exposed. Now, on premises, we have capacity. Well, Azure, whereas on premises we have capacities, probably VMs, maybe containers, Azure has a whole set of services to expose this capacity. VMs, containers, platforms, databases, machine learning, a whole set of different things. But they're provided by physical constructs. Now, the first one is a region. This is really the first physical component we use when we create a resource. We almost always have to say, well, what region am I deploying to? Now, there's a huge number of regions distributed globally. If we go and take a look, for example, here is Microsoft's kind of global map of regions, and we can see there's a huge number in the United States, in Europe, China, India, Asia, Australia, South Africa, Brazil is building out. So you can kind of go and pick, for the most part, any of these regions. And you'll notice there's typically always at least 2 regions in any geopolitical boundary, so that I can deploy my app, my data to a region, and have resiliency replication to another region that's hundreds of miles away, but in that same geopolitical boundary. I could go to East US to West US, North Central to South Central, Europe, etc. So we have all these different kind of regions. Now I can really think about a region being comprised of one or more facilities, data centers, and it's really bounded by this 2 millisecond round trip latency. So that means it could be many miles apart, but it's within that 2 millisecond latency envelope. Now, what you'll also see is Azure regions are actually paired. Now, you don't have to use these pairings, but it is recommended. So if I jump over for a second, this is my YouTube channel, by the way. But if I go and open up the paired regions document, what it actually talks about is what are the pairings. You can kind of see, hey, look, there's kind of East US to West US, East US 2 to Central US. It keeps it within the same geopolitical boundary. Now, the reason we might want to use these, and it is recommended, is that some services, like storage, globally redundant storage, it has 3 copies in the primary location, asynchronously replicates to the paired region where there's another 3 copies. Azure Key Vault, it has resiliency that it can fail over to the paired region. Backup builds on GRS, so the backup is replicated to the paired region if I turn on that geo redundancy. But additionally, beyond just maybe replication, Azure rolls out updates. When it rolls out an update, it will never roll out the same update to paired regions simultaneously. Because if that update had an issue, you don't want to take out the primary and the secondary. So in terms of service rollout, by using paired regions, I'm guaranteed to not get the same Microsoft update rolled out at the same time. So that's really probably the biggest reason to use those kind of paired regions. Now, some services also have built-in replication based on those region pairs, like, as I mentioned, GRS. Others you can pick. A lot of the database services, for example, the platform as a service, be it Azure SQL Database or the Azure Managed Database for Postgres or MySQL or MariaDB or Cosmos DB, I can pick where I want these async read replicas, or in Cosmos DB, it could even be writable. So sometimes we have our own flexibility. Even Azure Storage has object level replication where I don't have to use GRS. I could pick, hey, I want to replicate this container to this other container in this region I pick. Now, regions are selected based on considerations such as susceptibility to a natural disaster. I'm not going to build on top of a tectonic plate, for example, a meeting point. I'm not going to build in a floodplain, but it can still happen. There could still be a region level event. And so we have to consider, well, I deploy to a region, something could happen to the region. That's kind of my first blast radius that I could knock out the region. Then we get to availability zones. Now, a region, as I mentioned, is made up of multiple physical facilities. In some regions, they are exposed as availability zones. Now, each availability zone, there is no guarantee of distance between them. They might be miles apart, they might be a couple of 100 yards apart. The point is they are different facilities and they have independent power, cooling, and communications. So my goal here by using availability zones is to restrict kind of that impact that can happen. I'm restricting any particular fault that impacts one facility, be it power, cooling, communications, maybe a fire, should not impact another availability zone. So it gives me resiliency at the building level. Now, I'll see 3 availability zones. It is a per subscription logical mapping. I'll see AZ 1, 2, and 3. If I was to jump over, if I go to my subscription, if I say, for example, the simplest thing I could do is, hey, well, I'll create a new virtual machine. Now I have to pick a region that supports availability zones. If we think back to all the different regions, they don't all support AZs. For example, if I was to pick, let's see if I pick one. If I was to pick West US, availability zones here are not supported. But if I was to go to West US 2, I can pick availability zones and I'll see 1, 2, and 3. So I'll always see 3 availability zones. This is a per subscription mapping. And so I can think about, well, that availability zone could break. There could be an incident. There could be something that happens. And there is no consistency between different subscriptions. To kind of emphasize this fact, here I could think about, well, I've got this region. Now that region is made up, let's say 4 buildings. Could be 16, it varies. Then I have a subscription. Now my subscription 1, AZ 1, 2, and 3, point to buildings 1, 2, and 3. Just happens to go that way. My second subscription, well, its AZs point to completely different ones. Its AZ1 is the other one's AZ2. Its AZ2 is the other one's AZ3. AZ3 is a different building completely. There is no correlation between subscriptions. The point of availability zones is it helps me control isolation from instances. If I deploy 3 VMs to 3 different availability zones, I know those 3 VMs are in 3 different physical facilities. I'm minimizing the blast radius of something happening to any individual facility. There are some important terms that we really have to think about when we get to availability zones. The first one is zone redundant. So sometimes you'll deploy a service and it has an option of zone redundant. That means the service is automatically deploying across multiple availability zones for you. Nothing I need to do. It is redundant, resilient against any particular availability zone problem. So I don't have to worry about it. Then we have zonal. If it's zonal, it means it's deploying to a specific availability zone that I select. For example, NAT Gateway has a zonal option. I can pick, I want it to be in this availability zone. So it's not redundant against any particular zone failing. It's in one zone. So if I do zonal, I would probably deploy zonal instances to multiple availability zones. So I'd have a NAT gateway in AZ1, a NAT gateway in AZ2, a NAT gateway in AZ3, for example. But it's letting me control where it is, so I can make sure that I put the dependencies in the same AZ. I don't want these cross AZ dependencies. I want each AZ to be kind of self-contained and dependent, so any particular AZ failure doesn't impact resources in the other availability zones. And then you'll see regional. Regional means it's just deploying it somewhere. I'm not picking an AZ. There's no AZ exposed to me. It's obviously using physical facilities, so it may be something that's used by AZs. It may be that it happens to align with my AZ1. I don't know. I can't see it. By blind luck, it may distribute them over multiple AZs. It may not. When I deploy something as regional, I'm basically saying, I don't care about kind of AZ level resiliency. I just need this thing deployed. Now, you do want to be careful when you start using things like availability zone services that are zonal or zone redundant. Make sure you're consistent. I don't want to deploy some things as zone redundant, but then it depends on something that I have no control over. I won't want to have zone redundant services that use something that is regional, because the chances are that regional thing, if something happened to one building, it might take out that whole service. So you want to be very consistent when we use these things. And then there's availability sets. If I think about a particular building, it has multiple racks in that building. So what availability sets do is they say, look, we're going to spread this over kind of up to 3 fault domains. A fault domain is an individual rack. So I create an availability set, and then it just round robins distributes the resources over those 3 racks, those 3 fault domains. There's also update domains that I can pick between 5 and 20 when I'm doing staged rollouts of my app. When Azure is doing rollouts of its updates, it would only impact whatever percentage based on the number of update domains I have. Now, a key point here, though, is availability sets are being de-emphasized. They were there before availability zones. They give me resilience from a rack level or node failure. But obviously, availability zones are better because it gives me resilience from an entire data center outage. And additionally, there are a number of services now that are built on virtual machine scale sets where you'll see this FD equals 1, fault domain equals 1. That doesn't mean use one fault domain. What it's basically saying is distribute over as many fault domains as you can. So if I deployed, for example, a virtual machine scale set in a availability zone, and I set FD to 1, it's going to use as many racks as it can. It might be 5, 10. It's not limited to 3. So you are going to see now moving beyond the kind of 3 fault domains you have with availability sets and just saying, hey, look, distribute as much as you possibly can. Those are the key constructs that we're going to have: regions, availability zones, availability sets. So what does this mean? So you need to understand your service requirements, understand its dependencies, understand what is the recovery point objective, i.e. how much data can you lose in an unplanned scenario. In a planned scenario, you shouldn't lose anything because we should kind of shut it down, finish the replication, and then start it up again. What is our recovery time objective? How much time do we have to get up and running? Because those really are going to impact. Because if my recovery time objective is not super aggressive, maybe it's 8 hours, I can just redeploy the resources, maybe restore a backup. I'm fairly flexible there. If it's a very aggressive recovery time objective, I probably have to have resources up and running, replicating data, ready to start up. The recovery point objective is, well, how much data can I lose? Again, if it's very aggressive, hey, I can lose 10 seconds, I'm going to need to do replication. If we can lose 12 hours, maybe it can regenerate the data, I can probably restore backups. So the combination of the recovery time and the recovery point will drive, is it replication? Is it backups? Is the infrastructure ready? Do I have time to just redeploy it? And it's really just the state I care about. And you do obviously have to think about the cost. The further we go in terms of replication and ready to go means the resources are up and running. It's going to cost me more money. When I think about resiliency within a region, ideally what we want to think about is we like multiple instances. I want to think about at least 2 spread over availability zones or availability sets if availability zones are not in the region. Now, this could be virtual machines. It could be virtual machine scale sets. It could be worker nodes for Azure Kubernetes services. It could just be worker nodes for app service plans. It varies. But Azure is consumption-based. We like scale out, i.e. horizontal scaling instead of scaling up and down. I can add and remove instances very, very easily. That optimizes my cost. And obviously, the more instances I have, the more resilient I am. Now, if it's PaaS, there's often going to be options for maybe zone redundant, i.e. spreading over multiple availability zones. It might be, hey, it's zonal, so then I would deploy multiple instances, 1 instance to each of the availability zones. But make sure all components have equal resiliency or better than you need. I don't want to have it as, hey, I'm deploying to multiple zones, and then just catch up here. And then I have something else that's just in one availability zone. Because then if that availability zone goes down, my whole service goes down. I want to make sure I have equal levels of resiliency. So that might mean, hey, I'm zone redundant on my virtual machine scale sets. Then I'm using an Azure standard load balancer, which can be deployed zone redundant. I'm using a standard public IP. The skew of the IP has to match the skew of the load balancer. If I'm using NAT gateways, well, then I need to start aligning based on subnets because that's zonal. So I need to have NAT gateways in each availability zone and make sure my networking is set up the right way. But there's a lot of considerations around that. Now, this does include items like storage. Remember, storage has different resiliency options. By default, it's LRS, locally redundant, 3 copies within a particular facility. I can do ZRS. It will spread the 3 copies over availability zones. Then there's things like GRS and GZRS, where it then asynchronously replicates to the paired region, where there's another 3 copies. But within the region, I have to decide what is my resiliency. If it has availability zones, ideally we want to use those. Remember, if I'm using backups, and they can be GRS enabled to replicate to that paired region. So that's within the region. Definitely I need at least 2 instances of my service spread over availability zones or availability sets, making sure I'm using good components. If I have single instance resources, it's tricky. Make sure you use, for example, premium managed disks. That still gets you a pretty good SLA. As you start going down standard SSDs and standard hard disk drives, the SLA decreases. For really the good SLAs, you need at least 2 instances in availability set or availability zone. If you're going to use multiple regions, and really you should be, true resiliency is going to come from deploying to multiple regions because, again, something can happen. There's no such thing as some indestructible set of infrastructure. Even multiple buildings, if there was some natural disaster, maybe it took out the power grid. Yes, there's generators, but there's still limits. You can still fry components, an electrical storm, and it will go down. So when I think about multiple regions, again, it comes down to that recovery point, recovery time objectives. My DR to another region could be, hey, I have a DevOps pipeline, CI/CD. It might have ARM templates or Terraform. I can just rebuild the infrastructure pretty quickly. Again, it comes down to the state. Where's the state? Is it in a database? Is it on a disk? So is that replicating? Is that backup and restore? It depends on the recovery point, the recovery time objectives. I might run active passive, so things are running and then I can switch over. Something in the cloud that is common is active. I'm actually running in multiple regions. This not only gives me resiliency from failure, but now I have instances of my service close to the users consuming that service. So it's a better all-up experience for them. Now, the challenge here is, yes, recovery point, recovery time will drive those decisions. But the ability to use multiple regions in an active manner is really driven by the application architecture and that data layer. Because if I want to have active hundreds of miles apart, well, if there's a database, normally with a relational database, only one instance is the primary writable. So that second instance is hundreds of miles away. If it wants to write, has to go and write hundreds of miles away and get the response back. So there's going to be a latency. Now, if it's very read heavy, I can have a read only replica, async replica close to it. So there are things I can do, but I have to consider that. Maybe I can move to Cosmos DB and have multi-write. But my app architecture really will drive the practicality of active. But replication can be accomplished. It could be through the application My app running in VMs might have replication. My database, which could be part of Azure, the Azure SQL database, managed database for Postgres, MySQL, MariaDB, Cosmos, all have replication options to regions I can pick. If it's a VM, I can do a VM level replication, saying like Azure Site Recovery to another region or a different availability zone. A final closing thought: if you do go multi-region and it's public facing, I have to be able to balance the traffic. So if it's HTTP, HTTPS based, I can use Azure Front Door. That also will improve the overall connectivity by having edge locations close to the users to terminate the TCP, the SSL connection, then go over the Azure backbone to get big chunks of data, cache it, and feed. If it's not, then I can use Azure Traffic Manager, which is DNS based, that will really work for anything. It's just name resolution. There's also now the Azure Global Load Balancer that enables me to have this Anycast layer 4 that then redirects to external load balancers. So again, I have to have a method for people to be able to come in and then point them to services in particular regions. So that's what I wanted to cover. I know I'm at time. Thank you for watching. Obviously, we've got the Q&A block. I'm happy to kind of jump over and answer any questions I can. But if you check out my YouTube channel, I've got a lot of videos there that goes into much more detail about all of these things. I kind of quickly alluded to it, but if you go to my NTFAQ guy, I've got playlists here. You can see like I've got an Azure Masterclass, which is like 20 hours of content. And then I check the comments, so ask questions there. I will happily answer those. But thanks for watching. Have a great day.
It was definitely an amazing talk, as I can understand from our comments from attendees. We're a little bit late, but I think we'll be in time. So before we start our beloved part of the event Q&A session, I would love to make a little but really important announcement. So as you know, Geekle supporting different communities, and we'd love to see you among us at the Q&A Global Summit on the 2nd and 3rd of March. So either you are considering QA as a career move or have already started as a QA engineer, this event will help you get on top of practicing QA. You'll get 2 days and 14 hours to learn how to build QA from scratch, what mistakes to avoid, how artificial intelligence can improve testing experience, how to implement QA to development process, automated and manual testing yin yang, and of course QA career, past turns to take. And that's like not the main point. The main point is that you have time to register during a happy hour to get a ticket for a special price, $30. I'll paste a link in our chat right now. So please check this link and register for the QA Summit. So I'm adding to the stream our speakers, Philipp, John, and Paloma. So how are you today? It's nice to see you.
Hi, nice to see you too.
Hey.
Yeah. Same here. I'll go.
If I'm not mistaken, it's your second Q&A for today, yeah?
Yeah.
Okay, great. So I see a lot of comments, so your presentations were really good, but I would love to ask our audience to ask some questions as well, because we have 30 minutes to discuss questions. Okay, for at least to start, so just share your experience, how it's for you online summits, how it's working by you for now. So anyone?
Ladies first.
Yeah.
Yeah, so I like a lot sharing knowledge. So for me, being a speaker, it's much more than something related about business. I like a lot, so sharing knowledge with students, with people that are starting, and also with customers that I can help at the end to build something better and improve it. So for me, it's an amazing experience. It's my first time having experience in Europe, so it's quite different.
Cool.
I mean, I love doing these things. So my hobby is kind of, I mentioned my YouTube channel and creating these kind of whiteboard videos and talking about the technology. So anytime I get a chance to kind of help people understand the technology or maybe help them get a little bit further in their journey around IT is just an awesome opportunity to be able to be part of.
Yeah, you can also totally agree with both of you. Spreading and sharing the knowledge you have is awesome, and yeah, having the opportunity to share it on a global basis is even better. So yeah, that's a great thing.
Cool. And like first question will be from my side. So in your job, what is the most challenging thing? So what is more difficult and what is more pleasant for you?
I think it can vary by day, right? I mean, so one of the challenging things I know for me, so I deal with a lot of the cloud technologies, it's constantly changing. So one of the most challenging things can be kind of staying up to date with, well, what is there today and what is the right solution? And is there something new that would maybe solve a problem a better way? So that could be kind of thought of as a pain point, but it's also one of the things you enjoy because there's always something new to learn. There's something new to play with. There's some way you can kind of grow and try things out. So I think just whenever you have kind of these technologies that are rapidly evolving, it can be a challenge to make sure you're really embracing and understanding everything it's capable of to do the best for yourself and your customer. But it's also one of the most rewarding that it's not getting stale. There's always this new thing you can kind of go and learn and try out and solve problems in slightly different ways.
Yeah. For me, it's the same. So I started studying thing, and how much more I studied, more I realized that I know less. So it's like always learning, and I was trying to be updated with the new topics. So this is really hard. And at the end, what it's the nice thing for me when I see something that I helped to create being implemented. So this for me, it's like a song. Like I helped to create this.
Yeah, this learning is always a challenge. As a consultant, I saw already a lot of different applications from very different companies, and it's always a challenge to get accustomed to those companies and how they develop software, and then bring in certain knowledge to them, so they can in the end solve their problem. So that's always a big challenge, to get to know the customer and the company.
Okay, I was muted, and yeah, thank you for your answers. And is it like more, I know, philosophical question? So, do you think there will be always a need for solutions architect?
I'll say yes. I'll just start. So again, we've talked about this kind of in a previous Q&A, like there are these shifts in services, a shift in responsibilities. But if you think about a lot of those services today are around giving you a platform onto which you can apply your business logic. Now, there's more and more services that like software as a service, a complete business solution. But I think there's always going to be a requirement for more maybe custom to show your company provides this additional value over someone else. So I think there's always going to be an element of you need to bring elements and solutions together into exactly meeting your organization's requirements, be it that internal, be it for your customers. And maybe way down the line, you'll be able to kind of click a box, this AI will spring into life and say, hey, I can detect mentally what you want to do, and here's your new solution. But that's probably not in my lifetime.
Yeah, that's true. I also think that we will need solution architects in the foreseeable future, because there's always new things, and you can combine them in indefinite versions, and so you can always find new products by that, and further evolve. So I definitely would also say, yeah, we need them.
Yeah, I was thinking here. So when I started my career, most in Ericsson, there was a lot of solution architects. So I guess that you can be a solution architect for a different purpose, like for an industry purpose or for some cloud architect. So I think that we still have time.
And that's like really optimistic. Okay, we have like next question to Philip. So how can I measure my customer's size load to distribute among cloud data center deployments?
Oh, a tricky question. So the first good thing is here someone wants to measure. Measuring is always a good idea in a cloud setup because to find the best possible solution, first you need data you can base your choices on. And yeah, normally or most services in of those cloud providers don't really go on data center level. So in my opinion, you most often don't have really to choose your data center and how to distribute your deployments there. There are also a lot of services which help you to to distribute your application. So if you go for something like CloudFront in AWS, so you have those edge locations, and then you can easily provide everything and don't have to deal with the underlying stacks. And so it's a hard question to generally answer. I think this heavily is made up by the use case in the end. But measuring is always a good first step for that.
Okay, thank you for your answer. Is like next question is to John, and unfortunately we don't have banner. But anyway, how secure our data is on cloud while migrating it from on-premise to cloud like AWS or Azure?
How secure is the data in the cloud? So, I mean, one of the big things, obviously, if you think about all of the connectivity, so when you're moving it, it's going to be encrypted in transit. So I don't think it's even possible anymore to send data without it being encrypted. So in transit, it's going to be encrypted. And then once it's in the cloud, then there's different types of service. But again, those services will pretty much always encrypt it at rest. Now, one of the things you're seeing more and more of is when that data is encrypted at rest, you can generally use your own key. So there's an idea of a kind of system managed key where the platform is handling the key that's used to protect the data encryption key, kind of that key encryption key. But now some customers want even more control. So that key that's used to encrypt the data encryption key actually gets living in your vault. So you control that key that's actually essentially encrypting the data. So you could revoke that at any time. So that's how you can kind of think about the protection of the data at rest. But then there's obviously different levels on top of that. It's, well, who is allowed to actually go and access the data through various controls and the services. So then you think about, well, the network security, the identity security. Are we looking at some kind of elevated risk factor in the pattern or where they're coming from? And so when you look at the cloud service, in terms of the overall security of your data, you consider all of those things and you see services built on those different layers of the network, the identity, the risk detection, and the actual access to really help you. By default, it's secure, but there's things you can do to really control it, exactly what level of access you want to enable. So hopefully that answers the question.
Sounds sounds like that. Okay, we have like next question for Paloma. So eventing and microservices in IoT architecture. So your point of view.
Yeah, so it's very common also when we are talking about IoT using microservices, not just with container, but also using the power of functions. So I can use, when we are talking mainly about cloud, so I can use the power of functions and I can put some intelligence in my code to handle a specific kind of data that it's being streamed. So yeah, it's very common also. We have this kind of thing. And I mentioned in one of my slides when I was talking about the architecture. So it's very common we have this kind of deployment using APIs or even using functions.
Cool, thank you. And like one more general question. So do you think solutions architects should code, even just for fun?
So I'm probably the least coder in this group. I think everyone else is a lot better than me. And even I would say yes. So I really come from an infrastructure background, but if you look at today, even for infrastructure, there's the thing of infrastructure as code. The idea that, hey, we're going to design our infrastructure in some way that we can version control, we can track. We think about even automation, be it PowerShell or Bicep or other types of language out there. So I think there's a definite aspect, even for people that are not developers, and I'm not a developer, but to understand the basics of coding and understanding the basics around kind of DevOps, the version control, the continuous integration, continuous deployment, delivery, that whole set of skills, I think applies to everyone. So, right, I think even if you're not a coder, I think having some knowledge of the fundamentals is a useful thing. And that's me as a non-coder. So
Yeah,
As one who, oh yeah, please.
no worries. So yeah, for me it's the same. So when we are thinking about now about DevOps, so we have Terraform, and we need to have some kind of code inside, or even if we're talking about NoSQL database, so we need to work and we need to understand a bit about how this can improve. And having some knowledge in Python as well. So for instance, I just bought a book, so I needed to improve my knowledge about using Python because I know that this can be valuable at the end for me while design a new solution as well. So yeah, it is important. One more solution that we need to keep update.
Yeah, I totally agree with that. Myself, I love coding, so it's also the most fun for me. But nevertheless, so we have things like emergent architecture, so that the architecture isn't only set up at the beginning of the project, but it develops in the coding and development process of one project. So the one who sets up the initial architecture also should able to code or should see what the developers are doing and understanding, so that the architecture he thought about, he can bring it across to the developers more easily and get them to know it.
Great, thank you everyone for your questions, and I think like we'll have a little more one last question. So, how has like this whole pandemic situation affected your work? Okay, I would even paraphrase. Where was it affect except all this online stuff, Zoom meetings, and so on?
I can go first. So for me, I work from home anyway, so it didn't really change anything. There's a few less in-person customer meetings, but everything I did was pretty much virtual anyway. So it has not. I have to now train at home, so I had to set up my garage as a gym instead of going to a gym. But that's really the major change in my life. And I eat pizza at home instead of at the restaurant now. But apart from that, nothing really changed.
For me, it was quite interesting because I was based in Brazil. So I was living in Brazil, and I accepted a movement for Spain 1 month before starting the COVID. So I moved for another country, and so this is different because I have my colleagues from Brazil, and now I was going to create a new network inside the company. So, and I was needing to work all the time from home. So this for me was a bit hard, but with Zoom and all of this technology helped me. Same.
Yeah, for me it was really interesting to see because I was most of the time at the customer side. And they always said, oh, they don't like home office that much. They see a lot of problems and the IT and so on. And in the end, it all worked out for those companies quite easily to have their software development distributed and have the employees and externals at home. So I guess for our profession, it might be played out quite well. So we can have more freedom and flexibility where we want to work, when we want to work. So that's the main effect I saw on our work.
Okay, so I'm really thankful for your time, actually. So it's time to finish our Q&A, unfortunately, because time flies with you and I enjoy your company, and it's my pleasure to moderate you today, even though you were live on videos, but it was really nice sessions, and we received a lot of positive comments from our audience. So I remind our audience that all these talks you can find on our new Geekle educational platform. Link you can find in the chat. So I have to say bye-bye to all of you, and I hope to see you on our next summits. I hope it was pleasant experience working with us, and
Cool. Thank you for having us.
Thank you.
Thank you. Bye.
Thank you. Bye-bye. So times really flies. So one thing I want to also mention is that Geekle is running a challenge. So you can take a photo or video from our summit. You can share that in the social media, and I'm also now looking for hashtags. So here they are. So post it in your social networks using these hashtags. So Geekelas, Geekle-events, and Geekle-family. Tag us, and the most interesting and creative photos or videos will be broadcasted online really soon. So I think it's a great opportunity. Also, I'm excited to announce that you have still 30 minutes to the end of happy hour ticket for the Q&A Global Summit. So for now, you can take a chance to register at the lowest price ever, so $30. I'm posting link just now, so use this chance and it will be really great there. And actually, as I mentioned, time really flies, and time with you was amazing. So we heard a lot of amazing talks. We participated in exciting Q&A sessions. And now I have to say bye-bye to you and announce a little break. So we have 15 minutes to make some tea, do some exercises, or have fresh air. So I wish good luck to everyone. Stay safe and healthy, and stay tuned with Geekle. We'll have a lot of interesting things. Bye-bye.
Hey everyone, welcome to Worldwide Software Architecture Summit powered by Pickel. I'm Charlie Jensen, the moderator of this session, and for the next few hours, I'm gonna guide it, and I'm gonna invite a few interesting people. We will discuss the topics, ask some questions, and so on. But before that, I would like to tell you breaking news. Right now, there is a giveaway for tickets. So we really give them away for questions. Take a chance to win a ticket for an upcoming Pickel event at choice. Write your questions to our speakers in the comments. Use the question for ticket hashtag. And at the end of the summit, we'll randomly choose 5 lucky winners to provide with a ticket. Be active and let the luck be on your side. And now, ladies and gentlemen, I would like to introduce a new blog, and actually a new topic, quite interesting one. It's resolving technical debt in software architecture. You all know how painful it is, right? We all know those projects when whatever you do, however you plan it and so on, at some moment of time, you realize that there is an amount of this kind of debt and the things that you forgot to do or had something else to do and so on. So Carola is managing director at WPS, Workplace Solutions, and love to design good structured, long-living software systems. Since 2003, she and her teams are using DDD to achieve this goal. DDD and sustainability of software architecture are the topic of many talks she has given on various conferences. She condenses her experience from over 300 analyses of software systems in her book, Sustainable Software Architectures. So welcome to the stage, Carola Lilienthal.
Hi.
How are you doing?
Very, very good. Thank you. And you, how are you doing?
Well, quite interesting. I had a really nice and effective day by leading the team and then doing some coaching. So, what brought you to this topic? This is a very, very, very really hot topic. So something was really there, something to bother you, right?
Yes, well, I've grown up. I have been growing up in a university where they talked a lot about architecture, and we try to do good things. And then I wrote my doctor thesis on complexity of software architecture. So technical debt was not far away, you know, because complex stuff has depth in it. So, but I'm going to explain all this in my talk.
It will be extremely interesting to listen to that. Yeah. So start sharing your screen.
Yes,
I will add it
to that. Wait a second.
There's a few things. So once closer to the end of your presentation, I will jump for just a second. I'll step in and I'll say 5 minutes, and then 2 minutes, and then 1 minute. If you use your own timer, then even better. I don't need to bother you at all. But sometimes people are just so excited that they would not take a look and they accept this service. So if you need anything else, any kind of technical assistance, I'm also here.
I'm fine. I did this talk already once today in the European time, so it's fine. I'm used to that. I will check my time. No worries.
Okay. Good luck then.
Thank you.
So here we are. You go.
Thank you very much. Okay. Hi, everybody. My name is Carola. I'm from Germany, from a company called Workplace Solutions, and you can see my colleagues on the screen. They are all at home. I hope you are too at home, and they are all programming. We are 120, 130 people at the moment, and I have like 14 teams creating software for our customers and doing architecture consulting. And my job is to guide them. I'm the managing director, but I've studied computer science, as you have already heard. And today, I want to talk to you about technical debt and software architecture. Well, what is technical debt? Well, actually, technical debt is a wonderful metaphor to describe what happens in the lifetime of software systems. What kinds of technical debts are there? Well, I normally try to help teams with 4 categories of technical debt. The first one is the lack of documentation. I don't need a lot of documentation, but I think it's necessary to document some of your architectural decisions. So please write down why you did something somehow and not the other way around. This is important. Not enough unit tests. One of my main questions when people call me and ask me to come and have a look at their software architecture, how is your test coverage? Sometimes the answers are frustrating. Then there is implementation debt, long methods, everything you can measure with metric tools. And the last category, which is really the most interesting, architecture debt, which means that the design of your system is messy and everything is twisted around. And I will show you what this means and what we could do to prevent this. Let's have a look at what is actually happening with a software system in its lifetime. Imagine you had the most wonderful team of programmers and an architect, and everybody loves architecture in your team. You have a very good product owner who really cares for the functionality and gives you feedback, and you have a good management that is interested in a good software development process. And then you ship your system finally after a while of iterative agile development, and the users start to use your wonderful system and they want more. Of course, it's a cool, wonderful system and they want more. So let's have a look what happens. In the beginning, we're gonna fill in this diagram with the time. In the beginning, you get into the world with low technical debt on the left side of the diagram. And you would love to stay there. You don't want more technical debt. And over time, you create more and more functionality and the users want more. And the normal thing that happens when you change the system, when you do maintenance or when you add new features is that you accumulate some technical debt. There's a little bit of technical debt you take in because, well, the first solution for an enhancement is never the best. You try your best, but you have to think about it later on. And then the real good idea approaches and you would love to improve your architecture. And if you're in a good company, you can do it. You get time to improve. This is the little green arrow there. And you get down with your technical depth again. And if you can do this, you will stay in this corridor of low and stable maintenance costs. This is the ideal world. This is what we all would love to do. But unfortunately, life is not always like this. And if you can't do this, if you can't improve your architecture, every now and then your architecture will erode. And slowly but constantly, you will take in more and more technical debt. You get into some red area. You see the arcs change color. But if you look at it very closely, you can see that the arcs get smaller and smaller. And by this, I want to show you that over time, when the erosion gets more and more, you will end up with creating less and less valuable software. With the same budget, the same time, you will not get forward anymore like in the beginning. And if this really gets horrible, you will end up in this corridor of high and non-predictable maintenance costs. This is a horrible state. Nobody wants to be there, but a lot of people end up there. And the only chance to get out of this is refactoring, to get the structure, the design, the architecture back into a good shape, or to program the system again from the beginning. And me and my colleagues have looked at about 300 systems over the last 10 years, some of them in the low and stable maintenance cost corridor, some of them up there in the red, some in between. And what do? We analyze those systems. We take the source code and put it into a tool and discuss the architecture with the team, with the architects of the system, with all the programmers who want to talk to us. I've indicated some analysis tools that we use. I work very often with a sonar graph. I'm going to show you some pictures out of this one in a second. And then when we looked at the system, discussed it with the team, we come up with a number. We come up with a modular maturity index. We tell them, well, you are between 0 and 4. You are in this corridor of high and non-predictable maintenance costs. You are red. Or we tell them you are green. You're wonderful. Your system is in a good shape. You're between 8 and 10, or you are somewhere in the yellow. And the size of those bubbles indicate how big the software is. And for each system, there is one chunk on the x-axis. So the one axis doesn't give much information here. Okay, so what you see here are just 16 systems, and on this screen we have looked at much more in all kinds of programming languages: C++, C#, Java, TypeScript, PHP, ABAP, SQL as well, and they are of various sizes. Some of them are small, up to 100,000 lines of code. Some of them are much bigger. The Lilac ones are 500,000 or up to 1 million even, and we have seen very, very big systems up to 15,000 lines of code. And all of these systems have different specialities depending on their size, depending on the team that did it. And the question is, how do we organize it to say, well, you are red, you are yellow, you are green? Well, this comes from my doctor thesis. In my doctor thesis, I worked on complexity of software architecture. And my question was, what are complex architectures? What is actually complexity in architecture? And what I did to discuss this is I went into cognitive science and asked the cognitive scientists, well, listen, what does our brain do when we have to deal with complex stuff? What do we do? How do we work with it? And what kind of structures does our brain like to look at, to deal with, and in this process of liking the complexity has no problems to deal with it. Well, the cognitive scientists, they had some answers for me. They told me, well, our brain is very well organized, very well prepared to deal with complex structures. What is our brain doing? Our brain has developed over the years that humans are on Earth several mechanisms to deal with complex structures, to be quick in complex structures. And the three things that our brain is doing are chunking, we love hierarchies, and schemata. I will explain these three things to you and directly relate them to software architecture. What is chunking? Well, chunking means that we take all the little bits and pieces around us and put them together into bigger chunks. You're doing this the whole time. Your brain has around 7 to 9 storing spaces in your short memory, and you're all the time chunking to deal with this low amount of storage in the end. My sentences are much longer than 7 or 9 words, of course, so you are chunking all the time. But, and this is the important point, chunking is only possible for you, for your brain, for our brains, if the things that we try to chunk are strongly related to each other, if it makes sense how they are together. You're looking at me and you're chunking me. You're chunking me as Carola, the speaker. If I would have a water pipe here coming out of my shoulder, you would have some problems to chunk me. Your brain would be irritated. You would not be able to chunk me. And this is the point. And in software development, in computer science, we have a wonderful concept that is pointing to this, cognitive mechanism in our brain. We call this modularity. We speak about modularity, about putting parts of our software into bigger chunks, actually, into modules. But we have to understand this principle right to really work on chunking. What do we all know about modularity? Well, modularity talks about high cohesion and loose coupling. Things should be close together and loosely coupled to the world around them. And there are ideas of responsibility-driven design, separation of concern, and the single responsibility principle, a wonderful principle of Robert Martin. And the idea here is a class or a package or a namespace or a module, whatever you have, like units in your architectural idea on the level you're working on, they should have one responsibility. This is the point. Things that work strongly together should have one responsibility. And there is this little comic on the right side of the slide where two people are looking at the screen, and one of them says, it's crucial to find a good name for your class, which reveals its purpose. And then they look at the screen, and then the other one says, well, like crap, I don't know where else to put in. And the other one says, exactly. And this is the point. Naming is key. If you don't have a good name for your classes, packages, modules, whatever, there is some problem with the modularity because you're not able to describe the responsibility of this thing in one word, in a good manner. Okay. Let's go on. Hierarchies, wonderful thing. Our brain loves hierarchies. The cognitive science have done a lot of experiments with people, and they found out we love things that are hierarchical. We love things where we know this is the one on top and those are underneath. And we can do this in software. We can have hierarchical layering. I will show you this in a second. But before, I will talk to you about schemata, because schemata are wonderful. Schemata are ideas that you have in your head in your brain about the world. You have a lot of ideas in your brain about the world to categorize things and to recognize things. So if I tell you my both parents, mother and father, are teachers, your teacher schema starts to run and you think, oh, she had school at home, how horrible this must have been as a child. Or you think, oh, this is why she is talking so quickly. Whatever, your teacher schema started to work. But if I tell you my father was a hammer, there's nothing. You don't know this work. You don't know what these people are doing who are hammer. Well, hammer were the people who transported on horses and other animals the goods before we had trucks, lorries, trains across the hams of the Alps in Europe. I don't know if this exists in America as well, but in Europe they were called like this. But the point is not the hammer. The point is you didn't recognize this word. You didn't have a schema for it. And the other thing, apart from recognizing, is that schemata make us quicker. And the cognitive science did a wonderful experiment to show this. They took a chessboard and they put the chess figures on the chessboard and showed it to a chess expert, and told him, well, look at it and try to remember as much as you can. You have 20 seconds. And then they took the chess figures away and asked the expert, the chess expert, to put back as many figures as he could. And they did the same thing with people who don't know anything about chess. And the result was the experts could put back twice as much chess figures onto the board than those people who didn't know anything about chess. But this only worked as long as on the chessboard there was a reasonable setting of the figures. If there was nonsense on the board, both parties had the same results. The experts didn't do any better than the people who didn't know anything about chest. And here you can see what schemata help, because the chest experts, they have schemata about the settings on the board. And with those schematas, they were able to remember much more than the people who didn't know anything about chest, but only as long as the setting on the chessboard told them something, as long as this triggered a schema in their head. So now you know schemata are wonderful. They help you to recognize things, and they make you much quicker. And lucky we have a similar thing in computer science. And in our profession, we call this pattern. Design pattern, architectural pattern. And these patterns are wonderful because they trigger our possibility, our ability to work with schemata. But they only help if you use them consistently. So this is the third part of the cognitive mechanisms. And if you follow these principles, your software system will end up in a good shape. It will have low technical debt, and your brain will love it. It will love the structure. We will start with hierarchy now, and I will show you some software systems and how they look like if you really work on the hierarchy. This is just a diagram to show you what I'm talking about. In the 90s, we told people, please do technical layering. Do something like a presentation layer, application layer, domain layer, and infrastructure layer. Well, today we tell them more. Because we have huge software systems, we tell them, well, please cut them into domain modules. And if you need some coupling between them, then please at least have this layered as well. And don't do cycles in there. Don't do cyclic structures. I will show you now how this looks like in a software system. The first time I went to look at it, it was quite small. It had 100,000 lines of code. And the architect called me and said, well, Carola, I know you can have a look inside and you can help my people to reorganize, refactor a bit the architecture so it's in a good shape. Can you come by? And I said, yes, of course. For 100,000 lines of code, you go there for a day, and we worked on the architecture, mainly on the technical layering. And in the evening, they had like 40 refactorings to do. And I told them, listen, in a year, when you did this big enhancement you're planning, I will come back. And then I want to see a good technical layering and a good domain layering. And now I will show you how the system looked like when I came back. I will explain everything to you, so don't worry. You see here two pictures from the photograph. What is this? Well, what you see there are these funny little squares. Let's call them modules. These modules, we have created them in the tool. The first thing you do with a tool like this is you pass the source code and get in the structures, the classes, the packages, the relationships, and then you model onto this structure that you have, higher structures that you have in your head, like these modules. So if you would be able to look inside of one of these squares, you would find part of the package tree, some classes. Okay, so these are the squares. Some there is more inside. They have a darker color. Some are light green. There's not much in them. Okay, and now there are those arcs, and the arcs represent the relationships within the structure, which means that in the upmost module there is a class that needs something from a class down there at the bottom, in the square at the bottom, indicated by these green arcs on the left side. The arcs on the left side indicate a use relation from upwards to downwards. On the right side, they go upwards. You see the red one? Well, in a layered architecture, relationships from downwards to upwards are not good. And the layers, you can see them here. If you look at it from very closely, you can see that after about 10 squares, there is a bright line. And this is the end of the first layer. So up there is the user interface layer, then the application layer, the domain layer, and some infrastructure down there. And when we arrived at this picture of the technical layering, I was very happy with the team. And I told them, well, you did a good work. Almost everything is fine. There are only some little mistakes. One is quite problematic. There is a relationship from the business layer towards the user interface. And I looked at the architect and he said, oh, wonderful. This is a perfect picture. This is the reporting component. I knew that there's a problem with this component, and I always wanted to look inside and refactor it, but we never had time. Now I can go to my management and show them the picture and tell them we need money. This is impossible. You can't have the business layer calling something from the user interface. This is out of the way. We have to refactor it. And the yellow ones down there, they are just some little mistakes, easy to refactor. So we just we said they are not so problematic, so they are yellow. And on the other side of the slide, you see again a picture like this, but now the squares, the modules are organized from a domain perspective. So down there is the basic domain layer and other layers on top. And when I saw this, I praised them a lot, because we didn't do this in the first analysis. And here there are almost no mistakes at all, just 2 red lines and 1 yellow. And it's again the reporting component. So it's really, really good. And I told them that they did a real good work. Now I show you a horrible example. The same idea in the end, but here you see the real layers. So the layers are closed and the squares are inside. On the left side, you see the technical layering. This is a really huge system of 7 million lines of code, really, really big. And unfortunately, the technical layering looks fine, but there is one layer that is dark green. And this means there's a lot in there. And what's in there? Well, in there is this thing on the right side. This, well, in domain-driven design, we say big ball of mud. This monster of packages that all need each other. This is a system which is unfortunately in the red corridor of high and non-predictable maintenance costs, because you never know what will change if you just change one class. And what did happen here? I saw this system before. I saw it when it was much smaller, and I looked with the team on the class level. And here you see a class cycle. You see several class cycles, even the little brown one up there and the big one, 119 classes. All these squares are classes, and the colors indicate they belong to different components, but there is no up or down, no hierarchy. They are all needing each other, strongly connected with each other. And I looked at this and I said, well, please do something about it. Find out which class is rather on the bottom and which class should be rather on the top. And they said, yes, we will do that. But unfortunately, they didn't get time. And after 2 years, the thing looked like this. This is a class cycle now of 327 classes, all linked together from 8 different components. And well, I tell people, please be aware of your small cycles. Cycles are like dark holes. They pull other classes inside. And this is what happened here. And you see it. It's a dark hole. Why is it so dark in the middle? Well, it's so dark in the middle because all these classes are connected. All these classes in the middle are connected. And in the background, there are black arcs. And there are so many that it looks just dark. You can't even differentiate between them anymore. So this is really horrible. And the last thing I want to show you is now, what do we do with pattern and what do they help us in our software systems? Well, Patterns are wonderful, I already told you, because they trigger your possibility to work with schemas. I put some pattern on this slide. You see the user interface model view controller pattern, which is quite common. You might know it. Some of you probably work as well with domain-driven design or other patterns. I hope that you have something like a service pattern or and something like business objects or entities in domain-driven design and value objects. And the important thing about pattern is they not only trigger the schema task, but they do another thing. Pattern help the modularity and the hierarchy. How do they do it? Well, you remember modularity was about having a responsibility. And if you look at these patterns, their names indicate very well some kind of responsibility. If you your colleague tells you that he is working on the controller, you will understand exactly what he's doing there. The controller will never do anything on the user interface. He is just working with the view and the model. And the view is creating the user interface, but will never call the service. So by the name of a pattern, you indicate its responsibility. And if you look at it very closely, you can see that those patterns form a hierarchy. I'm pretty sure that you would start to think about it if the view in here would call the controller or the model would call the service or something like this. So patterns help modularity and they help hierarchies. And this is why they are so good. And we can look inside of systems, what they are, how they are built and how they are built from pattern. So what you see here is the patterns in a system organized together into one layer. So all the service classes are together in one layer, all the processes, importers, and so on. This system, when we looked at it, I was very happy about it as well, because the team really knew its pattern well. We were able to write them on a board. And the result was really good. We didn't find many problems in the system. The patterns were in good shape, and the people had documented that their patterns even. So if you are using pattern, please document them. I hope you got some little glimpse of why I love modularity and why it's important to look at the responsibility, at the coupling. We didn't talk about size and interfaces. This is for a much longer talk. I told you why hierarchies are good and how you should use pattern in your software. I hope you're not going away like this. I'm happy when you ask me questions. I will be there in the Q&A later on. And thank you for your attention. You can find me on Twitter. You can send me emails. My book has a website with some more videos where you can see what I'm talking about if I have more time on sustainable software architecture. Thank you very much. And now I will give the stage back to our moderator and to the next speaker. See you later. Bye-bye.
Hi, Carola.
Hi.
Thank you for this amazing presentation. I was listening to it because it's really like, I guess it's useful for everyone who's working in software development industry, whether it be a QA or DevOps or developer or APM.
Thank you.
Thanks for these nice insights. The best that I really liked was the connection between how the system works, what is the logic, and how our brain works.
Yes.
I'm a big fan of neuroscience.
Yeah.
So I really liked it. And yes, we can see how many connections are between the patterns.
Yes.
And especially now when these technologies are more and more look similar to our brain.
Yeah, that's true.
Thank you. It's going to be really interesting to hear from you and to read your book and so on. That would be great. Thank you.
Yeah, and I will be there in the Q&A. So if there are questions, just put them into the chat, and I will look at them before and then afterwards. Anyway.
Okay, sure. I will try to find out some place to ask my own questions as well.
Yeah.
Thanks. Okay. See you soon.
See you later. Bye.
Bye. And now I would like to remind you that today we have a giveaway of the tickets for questions. Be active, ask your questions, and you will be able to win a ticket. So our next topic is dedicated to using GitHub to automate and deliver technology projects. This is coming from Nick Beaugeard. Nick has been a solution architect and software engineer for almost 30 years, which is quite impressive, working in 3 continents and from startup to global enterprise, focusing on aligning methodologies and process with tools and technology. Nick spends his time helping development teams adopt to and implement new technology and integrate with cloud and DevOps. Nick has founded and successfully exited 3 companies already. Oh my God, that's nice. So, ladies and gentlemen, welcome our guest from Australia, Nick Beaugeard. Hi, Nick. How's it going?
Hey, good morning, Charlie. How are you?
Very well, thanks. It's night here, but it's morning in your location.
Morning here, absolutely. And the last session was 1 o'clock in the morning, so the timing's always good when we try and do worldwide stuff from down here.
Sounds nice. Perfect. Tell us a few words about what you like in general and why you picked up the GitHub as an example. In most cases, I used to work with GitLab CI/CD tools, not that much with GitHub. So what is the difference? Why GitHub?
Yeah, so I've kind of been following GitHub for years from its open source, where it started in the open source community. But the key thing I like about it is really anybody can pick it up for free and start running their projects with it. So it's gone from really being a version controlled source repository for open source projects to actually being a fully fledged management tool for everything you're doing, and not just software, but other types of development. So the opportunity for people to pick up this free tool and go run their project and extend it all the way up into doing large enterprise solutions and using it to manage it, I think is exciting. And I think people don't know it. It's kind of one of those hidden secrets in the industry.
Well, that's true. Plenty of people struggle to just use their habits to build like everything with Jenkins or Chefs and so on. While the repositories, they already provide sometimes even better service, which is embedded in their system. Okay, share your screen, please, so that I can add it to the to this session. And we are going live in a few seconds. Here you go. Good luck.
Wonderful. Thank you, Charlie, and good morning, good afternoon, good evening, everybody. I hope you're well. This is a session I've been building for a while, and it's a kind of a challenge. What I really want to land in this session is to give you a whole bunch of practical tools that you can use to automate and deliver technology projects of all sorts using GitHub. My history has been from at the turn of the millennium working with Microsoft and a bunch of internal tools to manage projects, through to using Microsoft Team Foundation Server, some of the Atlassian tools, and then into Azure DevOps, which is Microsoft's cloud-based solution, and now more and more into using GitHub. I've been working on a bunch of open source projects over the last couple of years, which drew me towards it. But now I find it's something I'm used to manage everything I'm working on. So I'm going to give you the way I use GitHub to manage and report on projects, and hopefully there's something useful in there for you. So let me give you some background on myself. My name's Nick Beaugeard. I've been a software architect for the last 25 years. I've been working in software probably a bit longer than that, as you can see by the gray hair. I've actually run, since I wrote that bio, I've exited another startup. So I've run 4 successful startups from scratch. I've run tiny teams up to really large teams, and love all sorts of aspects of doing that. And in that, delivered products from Microsoft all the way through to little applications and big startup projects and all sorts of different solutions the whole way through. So in spending my time delivering those solutions, I've really tried to think about what are the best ways to develop software? What are the best ways to work with a team? What are the best ways to deliver quality? And how do I roll that out across everything I'm doing? So my passion really, as well as creating cool products, is actually to work with teams to make them as effective as they can be in delivering innovative but quality code. And being around for a while, my background was actually in the move from waterfall development to agile development. And while waterfall development has very few saving graces, there's still some strange things that people do in the agile world. So it's trying to find a way to take all of those theories and all of those platforms, apply a practical bent to it, and try and get a feel for how you do those things from a practical point of view. So the goal of this presentation is for you to be able to do all of the things I'm showing you. I won't be able to let you try it in the 30 minutes, but there'll be some demos, and you'll be able to try this at home. So the technology we're going to use in this presentation, let me run through the list of what you'll need to do all the things I talk about. For a browser, I'm going to use Google Chrome throughout my presentation. You can use any modern browser. If you want the same results as me, just use the latest version of Chrome. I use a screen capture tool. The snipping tool comes with Windows 10, but you can use any screen capture tool you want, and you'll see where that gets useful when we're trying to describe issues and requirements later on. For editing documents, would you believe I don't use Word, I use Visual Studio Code, and I use something called Markdown to write all my docs, and we're going to talk about that in the session. So go grab yourself a copy of Visual Studio Code. You can go to code.visualstudio.com and download it for free, which is cool. Reporting on how your projects are going is really useful, and one of the the weaker places of GitHub at the moment is its management reporting, unless they're willing to log into a website, and most of the senior management I've worked with don't really like doing it. And it was only a few years ago where senior managers I worked with like to have all their emails printed out and they'd read them on paper. I think that's kind of moving on, but there's a tool which I've open sourced which allows you to use a GitHub repository and build out your documentation on how your project's going, or release specifications, and I'll show you that, so you can go download that for free. And I also use a tool called Pandoc, and Pandoc's used to take documentation I write in Markdown, or my team writes in Markdown, and make that available in beautiful formatted documents for customers. So those are the things you need. Those are the links. As we go through, I'll show you those again so you can go get them, but feel free to look at the video and grab that as well. So let's talk about what makes up a technology project. And I come from a software development background, but very few projects are pure software development. There's always lots of other things you put into them. And back in 1969, Dr. Winston W. Royce gave the now famous presentation to the IEEE, where he's talking about development of large-scale software systems. He worked on the Apollo missions. Is credited with being the father of waterfall. Well, I think if you read the whole paper, he's probably more like the father of agile, but we'll argue that another day. But core to any project you build is the documentation. And there's various places you do it. You document in your code, you write documents that sit around your project for your developers and the team building it to use, but you also write documentation for your customers on how to implement, use, support, and operate whatever it is you're building. And in some ways, the documentation is just as, if not more important than the end product itself. And I think lots of people see Agile as a way of getting rid of documentation. I see it as a way of really adding to what it is you're building and what it is you're doing. So documentation is important. I'm going to spend some time focusing on it. Some projects we've written actually were more documentation than they were code. So back in 2005, I sold a company to a global integrator. And actually, that was about the documentation, the set of instructions on how to do things. And we had a million words of documentation. And you need to think of documentation with the same rigor as you think about code. So things like the presenter before me was talking about architecture actually applies to code and documentation at the same time, which is interesting. The next thing is reporting. No project lives in a vacuum, and every project has a sponsor or somebody paying the bills. So you need to be able to report to them how your project's going, and that's super important as well. So I'd suggest you kind of keep an eye on that and think about that. And finally, it's the deliverable, whether it's your software platform, your SaaS application. whatever it is you're building. And I think every technology project has these three things. So to make it a bit more real and get out of theory, I'm going to use a real example, which is on my mind at the moment. So I'm working on a project called mForce, which is some cool meeting software, but it's been around for a little while and was originally written in a traditional legacy .NET framework. For those of you from the .NET world, we now call the .NET framework legacy, and .NET 5 is the new normal, so to speak. So the written in .NET framework, very traditional N-tier architecture, but it had no documentation, no bug tracking. There was no project management around it, and there was no issue management. So in this example, when we got hold of this, the old dev team had gone, it was a brand new team, we were just given source code. How do we start managing it? And I'm going to take you through the steps of how we start doing that and give you some demos. So let's get going. It'll be fun. So the first step is setting up your project. So with every project you do, you're going to want to follow some setup steps. Now, we can build this all into templates, but I'm going to unpack it and show you the various steps so you know what to do. If you're unfamiliar with GitHub, the first thing we create is what's called a repository or a repo, which is where we're going to store everything. So each project has one or more repos where we store collected together our code, our documentation, our issues, our tasks, our projects, our milestones, and our actions, which build everything together. So we set up the repo, number one. The next thing we do is we set up a bunch of labels, and this is going to help me categorize what the work items are in my project, be them bugs or work items or tasks or things that need to happen. So we put those together as well. So getting the labels set up, and I'll step you through that. The next thing we do, and whether we're starting a brand new project from scratch or picking one up, is I like to work off a well-known and well-understood requirement specification. What is it that we're trying to build and achieve? And traditionally, we'd have done that in something like Word, and it would have been a separate document to what happens in the project, and you try and map things together. But I'm going to show you how to do this within GitHub, so we keep everything in one place. And finally, I'm going to show you how to build the specification out of GitHub itself. So if you think about this, when I've done this, I've got a project that's living in one place where everything's integrated together, where if I go and change something, it changes everywhere, where the documents are real living documents this time, rather than somebody having to log into Word, which I think actually obfuscates the content and makes it hard to get to. So let's do some demos and learn how to do this stuff. Now, this is going to start off really basic for some of you who've used this stuff before. I get that, but I want it to be complete. For those of you who haven't, stick with me, because this will get more and more complex and exciting as we move on. So let me dive into a browser if I can. Here we go. And what I'm going to do to get started on this one is just go and click on repositories at the top. This is my GitHub thing. I've just logged into my page. And if I go and click on repositories, that shows me all the repositories I'm working on. Now for this, I'm going to create a brand new one. Which I'm going to call Sol Arc, or for Solution Architects Forum. And this is a repository I'll keep open after the session, and you can go log into and download all the bits and pieces you want. So I'm going to create it. Notice I haven't created it using a template. I'm not going to, because I want to show you the steps. So I'll make it public. In GitHub, I can make things private as well. I'm going to add a README file, which is the first thing you do. I tend to, by default, add a git ignore template. I write a lot in .NET, so I'll say Visual Studio is my template. And I'm going to choose a license, and I'll choose a fairly permissive license so that you can use the content I put up here at will. So I'm kind of comfortable with that. The next thing I'm going to do is I'm going to go create repository, and GitHub will go away, and it's now built the repository. So here's the first URL to remember, which is github.com/nickbo/solarc, right? Which is going to contain, when I finished, everything you need to do all of these steps. And you can go look at how I've set it up and muck around with it yourself. So that's the repository we're going to build. And that's how you set one up. There's not really a lot to it. They're very simple. The next thing is getting organized. If we look at GitHub, we have our code repository, which is what everybody knows it for. But the next thing we're going to talk about is issues. And issues is a name for just work items. They can be bugs, they can be tasks, and in our case, they can be requirements. So we're going to use the issue management system in GitHub to do everything from our requirement specification to manage bugs, to manage triage processes, to manage projects. So let's have a look at how we set up those labels. So once again, I'm going to dive into GitHub, and I'm going to click on the Issues tab. So once I'm in there, I have no issues, but I want to go and set up my labels. So you'll see there's a little button which says labels. Let's go find that. My PowerPoint's just pausing for a second while it has a think. And PowerPoint seems to have killed itself. That's always nice, isn't it? Let me go and get another browser up and see if I can fix it. Just bear with that while it's good. I love technical issues, aren't they? Nice in the morning. Right, and I should be able to give you a screen. Here we go. So hopefully, if I'm looking at StreamYard, you can all see my browser again. Excellent. So as I said before, we're going to go into issues. And I'm going to go and create some labels. Now, the labels I'm going to create in here are really quite important. These labels have each of the different items that our tools are going to use later to get things set up. So let me take you through some of them. We all understand what a bug is. A bug is something that's not working. And we have some others we add specifically. Functional rec is a functional requirement, and we need to create it as that. To create a new label, you go up and click on new label, and just type in what it is. So if I was going to create that one, I do functional rec, and I can type in functional requirement. I'm not going to create that one. I've already got it in here. But functional requirement is one I need to create. Non-functional requirement is the other one. I then create priorities 1, 2, and 3. And finally, I create one called triage. And triage allows me to actually go and categorize which of my issues I need to put into a meeting and which ones I don't. So I'm just going to reopen my PowerPoint because PowerPoint beautifully crashed on me. So let me go grab that one. And I'm just going to start my presentation from here. So what we've got is we've got a bunch of labels set up, which is kind of cool. And now what we're going to do is grab ourselves some PowerPoint. There we are. And we're going to go and get ourselves some requirements. So key thing to do is you get your repo set up, then you get your labels set up. Now we're going to go and complete some requirements. So let me just dive into here. So back into GitHub and back into issues, and let's go create some. So first of all, I'm going to create a new issue. Let's create a non-functional and a functional requirement. So my non-functional requirement is the product must be secure. Now, the text I'm writing in here is in something called Markdown. And if you're not familiar with Markdown, it's a really cool tool to learn. It's a text-based format which allows you to apply formatting to your text. So you can do bullet points, numbered points, tables, headers, all the things to make pretty documents, but in a textual form, which is really useful. Now, what I'm going to do with this is I'm going to apply some labels. I'm going to say it needs triage. We need to think about it. It's a non-functional requirement, and it's priority 1. So I'll just go and submit that first issue. So there we go. Our non-functional requirement, the product must be secure. Once I've done that, let's go and create another issue. And we'll create a functional requirement. So again, I click on new issue. And for this one, we'll allow users to log in. Now, when I'm telling people how I want things to look, what I'd really like is to give them some visuals of what I want things to look like. So in this case, what I'm going to do is I want to log in like the Office 365 one. So I'm going to create a new incognito window. I'll try and log into Office 365. Here it comes. It gives me that login box, which is kind of what I want. I'll use the snipping tool or anything which captures your screen to grab it. There we go. Grab that picture there. I'm going to copy it, which just copies it into the clipboard. And now I can go straight back into the GitHub window in the browser and paste in that image. And it will upload that image to GitHub and make it available. Again, let's give it some labels. So we're going to say it's triage, it's a functional requirement, and we'll give it a priority 1 because we should do it in our MVP. So that's got my non-functional requirement and my functional requirement set up. And you can see in that I've captured my images as well. So we've now created our repo, we've created our labels, we've gone and created our requirements. I know it's not enough for a product, but it kind of gets us started. Now, I'm having fun with PowerPoint this morning. It's crashing like you wouldn't believe. So I'm just going to fire it up again and see if we can get it to be a little bit more stable. Always, you test this 100 times and everything works, and then you try and present live and everything goes to custard. Let's see if PowerPoint is loaded. Here it comes. Okay, let me now go to producing a specifications slideshow from current slide. Okay, so the next thing we're going to do is go and produce our spec. So this is where I realized I wanted to keep all my issues in one place. So what I really wanted to do was create a tool that allowed me to do that. So we're going to give you a quick demo of that now. So let's go back into GitHub. I've got my project documenter. So if you go github.com/project documenter, you can find a bunch of versions which I've gone and created for that. So you can load it for Linux, for OS X, for Windows, but it's a really simple command line tool. The only thing you're going to need is to go to your settings, developer settings, and go and get a personal access token. I won't show you mine, but this is how you create one. And the personal access token will allow you to use the tool to connect to your GitHub repo. So once I've got that, I'll go back into there and make sure I'm in the right place. I know what that is. I can go to a command prompt. And in my command prompt, I can run the documenter tool. So I'm going to go documenter.exe. The repository will be Solarc. It's the last bit of that slash. The owner will be the Nick Bow bit, so the person who owns it. The document type, in this case, is going to be a specification or a spec. And then I'm going to put my token in, and I won't show you that. I'll just hide it. And when that runs, that creates a piece of Markdown. Now, I'll open that in Visual Studio Code, and you can see that it's built a whole bunch of information about this. To work with Markdown in VS Code, a couple of things I like to use is Markdown all-in-one. I'll just install that, and Markdown PDF. And I'll show you where the method in my madness is in a second. So we'll go back to the specification. I want to look at what that will look like when I build it. So I'm going to go to the command palette, and I'm going to choose Markdown all-in-one, open preview to the side. And when that opens the preview, we'll be able to see exactly what that will look like when it gets built. And to give it to my management for people to continue to work with, we can go over onto the left-hand side. We can right-click and we can choose Save as PDF. And when we save as PDF, it's going to create a PDF file that we can send to our customer with the specifications in it. So there we go. I'll let that look through. You can see my videos are looking lovely. And then on the left-hand side, I can just save that as a PDF. And that's done as a PDF. So really simple way. You saw I created a repo, created issues. I set up my requirements, my functional and non-functional requirements, and I turned that into a specification. And that now means the people reading the spec are actually reading stuff from GitHub issues, and everything's in one place. So once you're set up, what do you do to run the project? So to run the project, we do a couple of things. First of all, we run a bunch of meetings we call triage meetings. And I'll talk to you about that. But triage meetings are really where the team gets together and runs a really focused meeting to work on issues that we see. There's a bug management process, which I'm going to talk in some depth about, because the bug management process is where you get the quality in your product. The next one is producing deliverable documentation. And what I mean by that is documentation that you build for the customer or admins of your application or platform to consume. And the last one is building project documentation to report to your management on how your project's going. So let's talk about the triage meeting first of all. So we call these scrums or huddles or triage meetings. Everyone's got a different word for them. But these, I can tell when a team's working well because these meetings are 10 or 15 minutes. I can tell when a team's working poorly because these are 2-hour-long talk fests. What should happen in this meeting is you should work through each issue that's been assigned to triage one after the other as quickly as you can. You're not here to do design decisions. You're not here to debate architectures. You're there to work through the issues coming through the system. And for each items, you're going to do one of 4 things. The first thing you're going to do is assign it to someone to fix or change. You give it to a developer to work on. The next one is you look at it and say, we can't reproduce this. So we're going to resolve it. We're going to say it's fixed because we can't see the defect that's being mentioned or the bug that's being mentioned. The next thing is you resolve it and say, we won't fix this. So we love your idea, but that's not how we designed the product. And the last one is you say, we're not going to do that this version. We'll do it in the next version. And you'll see as you get closer and closer to a release cycle, more and more things get punted to the next version. But this is an important way to drive quality, and you use priorities to prioritize what your team's doing. And you can even enhance that with severities as you move forward. It's important that your triage team works as a peer team. Everybody works together to make a decision. The decisions are defensible. It's not a management from the top point of view when you're in the triage meeting. And if somebody wants to change to the product, triage has to approve it. And so setting that up and making that work in your organization is a critical thing to do, but can drive enormous quality and great projects. The bug or defect management. Now, this is giving you a really high-level overview to my view of how we manage bugs through the process. I've actually got a full document on this, so you can go to nickbo.github.io/released method. Make sure you do that with the capitals. But this gives you an idea of how the bug process works. So the person who finds it or wants a change, we call them the originator. The triage will process the bug and may, as you've seen, hand it to a resolver. The resolver will then fix it. And when they fixed it, they mark it as resolved and send it back to the originator. And then it's the originator's job to close the bug or send it to the resolver to fix again or send it back to triage. So those steps as you go through are super important to make sure you get the quality there. I've seen lots of people where the developer can close a bug as done. Well, who's going to check their work and make sure it really is? You need those checks and balances, and you can deliver them through the process. So let's talk about deliverable documentation. And this is documentation that you're going to send to your customer. Now, I like documentation to be written in Markdown. Things like GitHub and version control systems are really, really good at managing text and really bad at managing binary documents. So if you write them in Markdown, you can store them in GitHub, you can do version control, you can track everything with issues, but you're going to want to turn it into a final document. So let me show you how to do that. I'm going to use a tool called Pandoc. And Pandoc's going to take my Markdown documentation and turn it into a real document. So let's have a quick look at that if we can. So the first thing I'm going to do is I'm going to grab a copy of this repo. The way I do that is I create a folder. Let's go in there and I do a git clone, which goes and gets a copy of that repo. I'm going to do that in the command line. That's the last thing I'll do in the command line for those of you who don't like it. I'm going to go back into Visual Studio Code and I'm going to create myself a new branch. And the reason I create a branch is so that I can work without jumping over everything everybody else does. I'm kind of in my own little space here. So let's create a folder called documentation. There we go. And I'm going to create a folder under that called img to store my images. So in documentation, I'll just create one file. I'll call it readme.md. There it is. And we'll start putting some text into it. There we go. So there's my text. And we know in Markdown, we can have a look at that. It can look a bit prettier. But really what we want to do is get that checked into the repository so that everybody can look and review with what I'm doing. So I'll just do that. I'll select everything. I'll check it in. That's checked in locally. And then I'll synchronize that back up to GitHub. So let's do that. So now in GitHub, I have two branches. I have main and I have documentation. And what I'm going to do here is I'm going to take my documentation branch and merge it into the main branch by doing a pull request. So I'm kind of showing you that if you know how pull request works, that's cool. If you don't, go research them. They're super tools for working with your team. They allow me to get together everything I've been working on and make it come together and make it happen. Now, my machine's obviously crashed. So again, PowerPoint's died. So let's show you what happens here. So once I've got my Markdown and I've edited my Markdown and made it a bit bigger here, what I've done as well is created this thing called title.txt. And this is something that Pandoc uses to create the document. So what I'm going to do as my PowerPoint reloads, thank you, PowerPoint, is I've got that all set up. I'm going to create a little command file called buildme.cmd, and that's going to use Pandoc. It's going to output a document called solarch.docx, It's going to create a docx, that's a Word document. It's going to use title.txt, readme.md, and after that, I can put whatever markdown files I want. So once I've created that, I can go into my documentation folder. I can run build me. Let's just see. Build me.cmd. That will run pandoc, and that will have created this document here. Let's go and have a look at the document. Here it is in my file system. And if I open that in Word, which is loading now, you will see that it's gone and produced a fairly nice document in Word with each of my things there. So I can go and add all sorts of bits and pieces to my documentation, have all sorts of markdown files that my team work on, and be able to deliver that as PDF, Word document, etc., whatever I want. Really good way to deliver customer-ready documentation. So again, when we're doing documentation on where the project is, you can run the documentation tool I showed you earlier. Instead of building a spec, you can actually build a project status. So you doc type is project, and that builds a project status. So let me show you where I get all of that from. I'm going to go into GitHub. GitHub has a bunch of things. We've seen issues, code, and pull requests. We can also create projects. So in GitHub, you have the ability to create a project, which is a Kanban board of where all your different items are. So if I load this, you should be able to see that in progress, I've got this, need testing, I have this, done is this. You can have as many projects as you want. And if you use the documentation tool, it will document every one of your projects and where things are. The neat thing about this is it gives you the ability to drag around your various tasks, and everybody can watch those happen in real time. So as you're building out a task list, managing your project, and building a Kanban, that's how it all comes together. The documentation tool I showed you earlier will also give you a full project status update of what's going on there. So let's go back to our slideshow. And let's talk about how this is applied to our example. So I've been using modified versions of this process for years now, but what's happened with our example is we've now got documentation in Markdown, both the end user documentation, which is published directly from GitHub using Actions, but all our internal documentation is viewable either on the GitHub UI or through Visual Studio Code, and it's all a lot better. The code is being worked on through issues, which means we're tracking changes and linking them back to defects and things we need to do. We have a regular triage, which means everybody's up to date on what's happening, and it's efficient and it's quick. The quality of the project and its visibility has dramatically improved, and our delivery cadence has improved. So really, in conclusion, right, and to wrap up my presentation, which I've enjoyed, and I hope you've enjoyed listening to it as much as I've enjoyed building it. GitHub is a superb free tool, which allows you to manage projects of all types. And even if you start paying for bits and pieces, it's really, really cost effective. But you can do all of the stuff I've shown you today with the free tool. Right? Used properly, you can drive any type of project using it, including proprietary code, open source code, or just documentation. So I use it as a tool for everything I work on, whether there's a code component or whether there isn't. The version control, issue management, and projects really helps me to keep organized, and all of my projects can roll up into one set of issues. So I can see everything that's going on in one place. Every other tool I showed you today was free as well. Right? So if you want to have a look at all the links and the stuff I uploaded, go to github.com/nickbo/solark for links and more. And finally, if you want to see if I can put my money where my mouth is, sign up to get early access to our beta. It hasn't been released yet, but when it is, you can see if this method really delivers quality code, and you can go and get a free access to our beta at makemeetingsmatter.com. So that's me. That's my presentation. I hope you've enjoyed it. I'll hand back to our delightful moderator.
Hey, welcome back. Cool. Yeah, I enjoyed it, and thank you for sharing these really amazing tools. By the way, speaking about your approach to using GitHub and all this nice stuff, I didn't even know that they already have these nice workflows and task tracking and all the stuff around. I heard about Markdown before, and sometimes it's really useful when, well, especially when you use like a microservice architecture and you reuse some modules and code across the company. So sometimes you're just really happy when you can take a look at that code or that branch and you see the documentation related to it, rather than desperately looking for it in somewhere in Google Docs or Confluence or Basecamp, whatever. You know this pain. So thank you for sharing this. This is really an interesting and nice approach. Tell me, please, would you come back to the Q&A session?
Absolutely, Charlie. I'm more than happy to be there. I'll take any questions.
Perfect. We start our Q&A session in 20 minutes, and right now we're switching to our next speaker.
Cool. Thank you, Charlie.
Thank you. Thank you, Nick. Now we are moving forward to our next speech. This is a previous recording because this person couldn't attend to our meeting so in live, but we have a pre-recorded video. And the topic is architecting high-performance analytical solutions using Snowflake. For the ones to know, Snowflake is an amazing data control system provided by Amazon, and it allows plenty of modern cloud computing, distributed data storage. It can like raise the environments in just a few minutes and so on. It's really powerful and amazing tool. So our speaker, Sanjay Kattimani, his son Rishabh Kattimani, by the way, was on our Python event as a speaker. So they have good connection with GitHub. Over 16 years of experience in IT industry, this is Sanjay, 10 plus years of experience working in North America with solid professional experiences working as solution architect, data architect, and so on. There's plenty of different use cases and professional cases. Deep familiarity with cloud and on-premises data warehousing and RDBMS technologies like Snowflake, MS SQL Server, Oracle, Cassandra, Mongo, and so on. So right now we are starting this video. It would just take me. Okay, Sanjay is actually here and live. Okay, I'm really happy to see you. Let's start this then. Let me add you to the presentation. Hi, Sanjay, how are you? You are muted. Can you unmute yourself, please?
Sure.
Okay.
Hey, Charlie, I'm doing well. How are you doing?
Very well, thank you. I was just presenting the video and then I saw you actually come live, so I'm really happy to see you.
Yes, please. Please play the video. I would be standing by.
Okay, then we are. Can we see you on the Q&A session?
Sure, I will be there. Okay,
thank you so much. Then just a moment. This video will start just in a few seconds. I'm gonna play some random image instead of my Just a second, please. Am I right supposing that there is no sound on this video? Can you hear it very well? So there is no sound, right? Okay, give me just a second, please, and I'm gonna restart in just in a few seconds. Thank you.
Together, and most importantly, can we accomplish these goals? Hello everyone, I'm excited to have you all on this session. I'm sure most of you heard about last year's biggest IPO in software history. It was Snowflake, and for good reasons. In this session, we are going to explore what makes it unique, a brief about its features, and we will also look at a couple of reference architectures to build high-performance analytical solutions using Snowflake. Let's get started. My name is Sanjay Kattimani, and I'm a solution architect by profession. I've been using Snowflake for over 3 years now. I'm a SnowPro certified and also a data superhero of Snowflake. Whenever we are choosing a modern analytical solution, we almost always come across these fundamental questions. Can our underlying architecture scale to meet the needs of our fast-growing business? Can our product ingest and analyze large amounts of structured as well as semi-structured data together? And most importantly, can we accomplish these goals while remaining operationally efficient and cost-effective? Welcome to Snowflake. Snowflake is a single integrated platform delivered as a service. It features storage, compute, and global services layer that are physically separated but logically integrated. Data workloads scale independently from one another, making it an ideal platform for data warehousing, data lakes, data engineering, data science, modern data sharing, and developing data applications. Let's quickly look at what makes Snowflake's architecture so unique. Snowflake's centralized data storage layer is designed to support sub-second query response times against multi-petabyte table sizes without explicitly partitioning the data. Snowflake also provides native support for semi-structured data types such as JSON. In addition, Snowflake fully supports ACID transactions with fast insert updates, delete merge operations. Your data is also highly secure with Snowflake's many built-in security features. Snowflake encrypts all data at rest and in transit. Snowflake's computing layer is fully decoupled from storage layer and runs virtually any number of workloads on their own dedicated computing clusters, even if these workloads access the same underlying data. Dedicating computing resources for each workload avoids the drawbacks of running all workloads on a single large cluster, such as having a queue to drop workloads or engage in the costly and time-consuming effort of increasing compute capacity. With Snowflake, computing resources are independently sized based on need of each workload. And Snowflake provides a usage-based pay-by-the-second business model with zero cost when a workload is automatically suspended. Snowflake's cloud services manage client sessions, metadata, transactions, query planning, security governance, and other services. It is also highly scalable tier. Snowflake supports thousands of customers' accounts and hundreds of millions of queries each and every day. With each of these layers being independently scalable, whole Snowflake ecosystem becomes highly scalable to meet all modern analytical systems demands. Now let's explore some of the features of Snowflake. Snowflake separates compute and storage so you can scale each of these independently and cost effectively. Snowflake automatically scales compute resources up and down for near infinite concurrency without impacting the performance or having to reshuffle data. These compute resources are needed to query, ingest, or for most of the other data operations. Align costs with your product margins with pay per second compute pricing and avoid paying for idle resources. Ingest and immediately start querying JSON, Parquet, Avro, ORC, and XML data without defining schemas in advance. Deploy on any cloud regions with global replication for high availability, data durability, and disaster recovery. With zero copy cloning feature, you can quickly create sandboxes and develop pilots with live data but without the cost of copying and moving the data. A great use case of this feature is to create a replica of production environment in a matter of seconds to troubleshoot the issue without incurring any additional cost or time to recreate an exact copy. Time travel lets you easily access historical data after it has been modified or deleted for a period of up to 90 days. With a wide variety of connectors and drivers, you can integrate easily with native clients and connectors, including ODBC, JDBC, Node, Python, .NET, Go, Spark, and Kafka. Use SQL for all your data, structured or semi-structured, including support for joins across the data types, databases, and external tables. You can extend Snowflake with in-engine JavaScript functions to perform custom calculations. Automate the steps to transform and optimize continuous data loads with Snowpipe and third-party data tools. Share live data easily and securely with your partners, but without copying or moving the data to ensure a single source of truth across your ecosystem. It also offers security features to protect your customers' data with role-based access controls and data encryption at rest and in transit. Partner Connect lets you easily create trial accounts with selected Snowflake business partners and integrate these accounts with Snowflake. Fivetran is one of the integration partners who provide connectors to Salesforce, Google Analytics, and many other such standard. ThoughtSpot is another one that integrates very easily with your Snowflake and creates AI-driven analytics on your data. Metilin is a great ETL tool on the cloud. DataOps by Datalytics is another great tool that provides end-to-end orchestration, environment management, CI/CD pipelines, automated testing, and ELT wrapped in one elegant UI. Snowflake's marketplace is an online transactional location or store that facilitates buying and selling of data. A data marketplace is more a public form of data sharing and sometimes commercial or monetized too. Live COVID-19 dataset is one of the most popular dataset on Snowflake's marketplace. I tried this data set a couple of months ago and I could query and figure out a number of details such as how many COVID patients are there in a given zip code, or which country has the most COVID recoveries in a given time period. You could also combine this with the number of hospital beds available in a given zip code and figure out how many hospitals are running out of beds. You could also chart out projections based on available data to predict the future scenarios. It was very interesting. That was just one of the example, but then you can also see there are a number of categories and you will find data set on each of these. There are a number of such interesting data sets available on Snowflake's data marketplace. Again, the consumer will be paying for the compute, whereas the storage is already paid for by the owner of this data set. With this good understanding about the features and architecture of Snowflake, let's take a look at a couple of reference architectures to create high-performance analytical solutions using Snowflake. Customer's 360-degree view architecture is one of the most widely used architecture to build sales and marketing applications that use historical and real-time data to accomplish 360-degree view of customer goals, such as finding new segments and sending personalized offers. In this architecture sample, we have cloud object storage that stages application data such as data on products, audiences, purchase attributions, and user activity for ingestion. A streaming service ensures reliable and continuous ingestion by buffering event data such as click streams. ETL services orchestrate the workflow to load data from cloud object storage into Snowflake. Snowflake secure data sharing enables data from third-party sources to be used without copying or moving the data. Snowflake supports all analytical workloads within the application. External tables support queries of data in cloud object storage without ingestion. Streams and tasks features automate the ingestion and data enrichment process. Native support for JSON and other semi-structured formats simplifies the data ingestion of event data. Secure data sharing enables monetization of fresh data without copying or moving the data. Machine learning models are trained to optimize offers based on historical data stored in Snowflake. The application can make real-time predictions via an API and uses Snowflake tables to store input data and batch prediction results. Application health and security analytics reference architecture analyzes large volumes of log data to identify security threats and monitor application health. The application and its infrastructure log large volumes of event data that can be used to monitor application health and detect malicious behavior. Log collection and aggregation systems centralize log data from multiple sources and deliver it to streaming services or to cloud object storage. Streaming service buffers log data to ensure reliable and continuous ingestion. Depending on which log collector and aggregation system is used, data can be staged in cloud object storage without the need for streaming service. Snowflake stores and analyzes the log data, which can be saved for long period at commodity storage prices. Snowflake with auto ingest automates the ingestion from cloud object storage. Scheduled task invoke SQL-based queries to detect suspicious behavior or application health concerns. External rule-based alerting systems such as Snow Alert can detect suspicious activity or health concerns. Operations teams can monitor the application via dashboards or ad hoc queries. A messaging service such as Amazon's SNS or Twilio uses email, SMS, or push notifications to notify operations teams of events that require attention. Security information and event management systems such as Splunk can leverage data in Snowflake for advanced searching and alerting capabilities. This reference architecture is for Internet of Things to build applications that analyze large volumes of time series data from IoT devices and respond in real time. Smart devices, sensors, and other IoT devices generate continuous data. Due to frequent unreliable internet connectivity, IoT devices communicate using MQTT protocol and IoT message broker. The message broker uses publish and subscribe mechanism to interact with other services which subscribe to the specific topics within the broker and access the service data. A streaming service is used to ingest and buffer real-time device data, thus ensuring reliable ingestion and delivery to a staging table in Snowflake. In cases where the application requires it, cloud object storage is used to stage batch data prior to ingestion. For example, IoT device may be sending data every second, but it may get aggregated over longer period and may be stored in Snowflake. Snowflake offers native support for JSON and other semi-structured data formats for easy ingestion of IoT device data. Snowpipe automatically optimizes time series queries by ingesting data chronologically. Snowflake's streams and tasks features automate the workflows required to ingest and aggregate incoming data. An IoT rules engine hosts the business logic required by the application and operates on data available in Snowflake and in the message broker. The rules engine sends messages back to control the devices. Our next reference architecture, machine learning and data science, is to train machine learning models to build predictive applications such as recommendation engines. Application produces training data which Snowflake ingests via streaming services or via cloud storage. The streaming service buffers the training data to ensure reliable and continuous ingestion. When cloud object storage is used, the streaming service batches training data into larger chunks to lower API storage expenses. Snowflake ingests data into staging tables. When new data is detected, the streams and tasks features schedule required transformations. Multiple streams and tasks can be chained to implement complex data pipelines. External tables support queries of data in cloud object storage without ingestion. Data scientists can create zero-copy clones of the training data to support feature engineering and experimentation. Using the data stored in Snowflake, data scientists train models with machine learning platforms and available libraries. Once the model artifacts are trained, they are deployed on training platforms or on separate processes to support predictions. Moving on to the next architecture, that is serverless data stack. This architecture is for data-intensive applications that run on serverless infrastructures. The client-side apps running on mobile or web devices invokes the application logic on the serverless compute via API gateway service. The gateway service authenticates the API calls and throttles them if needed based on SLAs. Serverless compute runs the application logic and scales on demand without the need for provisioning or managing the servers. The application queries the Snowflake data for runtime decisions such as delivering product recommendations or powering the dashboard for analysis. An OLTP or NoSQL database provides the application with high-capacity transaction processing. This NoSQL or OLTP database can also be a serverless service. An ETL serverless stack orchestrates the workflow and loads transaction data into Snowflake. Snowflake ingests data in batches or in streams and makes it available to the application for queries. Snowflake scales automatically to keep pace with the data pipeline and ensures data is always fresh. Workloads are isolated in virtual warehouses where they can run and scale concurrently without resource contention. That was about serverless data stack. And now moving on to the last reference architecture, which is on streaming data stack to build data intensive applications that rely on streaming data ingestion and analysis. The producer application generates continuous data that the streaming service ingests and buffers to account for data rate differences between the producer and consumers. Depending on the application's needs, Snowflake ingests data directly from the streaming service or via cloud object storage. Snowflake ingests data from the streaming service into staging table and stores streamed data for analysis. Multiple streams and tasks can be chained to implement complex data pipelines. Snowpipe with auto ingest automates the data ingestion from cloud object storage. Regardless of what type of applications you build or what architectural design patterns you select, you must meet the core data platform requirements for scalability and connectivity if you want to attract and keep customers to grow your business. With Snowflake, you can meet customer expectations with modern foundation of your data stack that delivers a highly performant service both now and in future. That's it about the reference architectures. To conclude it, this 30-minute session was intended to generate enough curiosity in you about Snowflake, and by no means to cover every architectural details. If you haven't started your Snowflake journey, I highly suggest you to try it out with 30-day trial account. I'm sure you will love it. Signup.snowflake.com lets you register on Snowflake site and use their trial account. Thank you all for joining my session today. I'm available on social media and you can easily find me with my first name and last name. That is Sanjay Kattimani. I'm available on YouTube, LinkedIn, and Twitter. I would love to connect with you. Questions and answer session is coming up shortly. Looking forward to talk to you all. Thank you.
All right. It was a really good video, and to me it was curious to hear a little bit more about Snowflake as I just started to deal with this technology, and now I'm really excited about it. So now we are moving to the Q&A session, but before we go there, I would like to remind you one interesting thing is that we would love to see among us at the React.js Case Study Festival on March 16-17. Either you're considering React as a career move or upgrade to your JavaScript knowledge, or have already started as a front-end developer with React, the event will just help you to think out of the box and master the React.js practices. So what you'll get, that will be 2 days, 14 hours in 2 time zones to learn battle-proven React.js case studies of top companies at AWS, Facebook, Code Academy, Product Hunt, and others. You'll learn how to make your front end accessible to everyone. You'll know more about hooks and more and more and more. So please find out the URL that I'm just sending, putting to comment to your YouTube. So just let me duplicate the URL one more time. Cool. So welcome back to the Worldwide Software Architecture Summit, and we are moving to the Q&A session. I will invite now Carola and Nick to the stage. Hey, how's it going?
Hey, Carola, how are you?
Fine, thank you.
Hey, look, so we've got a few questions.
It's not there? We don't put him on the screen too?
He's not connected at the moment.
Oh.
but whenever he gets connected, I'm going to bring him online.
Okay.
So, the very first question that I probably would address you is from one of our commenters on YouTube. That was a question to Carola. So, it is from Lucas Mireles. Let me bring this to the table. Did you already find any conclusions on the use of DDD on producing better or worse architectures?
Wonderful question. Yes, of course. From what I told you before about chunking and about hierarchies and about pattern, you will find all this in DDD as well. The principles and the ideas of DDD really follow these principles, which made me very happy when I read about it. You have these building blocks in domain-driven design, which are called entities, value objects. You have services, factories. So and these building blocks are actually patterns, design patterns. There is no other name for them in the end. And if you use them, you do a lot of good stuff to your system. With the idea of bounded context, you get the system cut into domain modules, which I talked to you about as well. And well, these patterns, they form hierarchies. So of course, I mean, really, if you do it right, if you really use domain-driven design as it was described in the books, it will do a lot of good to your structure. That's for sure.
All right, thank you, Nick. What would you say about this?
Yeah, I think the question's awesome, right? So it's that age-old question of where we have all these theoretical patterns and principles, and do they actually make a difference? So it's useful to chat to someone like Carola, who obviously has just a deep breadth of knowledge with all those projects she's reviewed, to actually go, yeah, you know what, it does make a difference. It is better, because there's 100,000 concepts we're hit with every day. Do this, it'll be quicker. Do this, it'll be better. My way is better than your way. And I think one of the things to remember is these are just, you know, models and frameworks to help you conceptualize what is a large software projects are very complex, and to help you conceptualize and manage and operate and efficiently deliver a good outcome for the customer. So it is interesting to get the feedback, though, that these things aren't just, you know, theoretical, ivory tower constructs. They're actually things that work really well.
All right. Yeah, thank you. Good answer, by the way. So going a little bit deeper with that question. I mean, in general about the architectures and patterns and all the stuff, just to evolve it a little bit. So what would you consider as a healthy approach of using some patterns and so on, and a few unhealthy signals? So even before analyzing some signal, let's imagine that everyone in the team, they're hardworking, and you know, they sometimes cannot just focus on a bigger picture. But we can still listen to some signals, to some obvious things, in order to define, are we still going the healthy way, or we stepped into a wrong path?
Well, it's difficult to give a general answer, I think. I mean, I hope you think the same about this, Nick. But when I get to when I visit a team and I meet people who are very tired, and when I'm talking with them, they tell me, well, I had to get up last night because some server crashed or whatever, you know. I mean, then I know they really have a problem, you know. And if they last week someone called me and said, well, we need you, we need some help, we don't get forward anymore. And I said, well, what do you have? And they said, well, we have 3 million lines of Java code. Well, this is something, but there are bigger systems out there. And I said, well, okay, but yeah, how many people are programming it, are maintaining, enhancing it? Well, 30 people. And I said, well, this is, I mean, if they are programming and repairing bugs and creating new stuff, this is a good story. And the other side said, oh no, but the problem is they are just fixing bugs. They don't have any time to program anything new. And this is not good, you know. I mean, from looking at teams that work well, I have seen that you need about, I mean, for 3 million lines of code, you should have 12 people fixing bugs and not 30, you know. So, I mean, there are some numbers you can relate to, but of course it depends, you know. If it's a very, very complex domain, then this might be 15, but 30 is really too much, you know. And with some of these figures, you can tackle the people, and you can just ask them, what's about your unit tests? Do you have test coverage, you know? And if the answer is, oh, you mean those things with green and red line and blah, you know, oh, this will be horrible. You know, it's just, I mean, basic questions, things they told us 20 years ago, you know?
Right. Okay, I'm sure. Thank you. You're right. First of all, the people that are tired and people that always have plenty of work in the system, usually it's one of the first signals of an unhealthy signal. Especially if there's plenty of this, it's not just one, there's plenty of people doing the same. And second is the lack of unit tests or whatever test coverage. So the lower is the test coverage, the worse it is.
I have worked in teams with 80%, 90% test coverage, and they love to find bugs and they love to change stuff, you know, they enjoy it. They are not afraid. And if you have a team that is afraid to change something, you know, you have a problem as well.
Right. Okay. So the third thing there, so the first is when people are just overwhelming with all this work. Second is poor test coverage. And well, the main thing there is just, I don't know, probably an understanding of how much it is covered right now and how to maintain this system in an easy way. All right, let's move forward. There is the next question, and I can see Sanjay is getting back. So let's add him to the stream. Welcome, Sanjay.
Hey, everyone. Hey, everyone. Sorry, I had some technical difficulties.
No worries. So I have a question for you, by the way. It is coming from Jose Pineda. It says, what would be the advantage of using Snowflake over Vertica?
Sure. So first thing is Snowflake is built for the cloud and Vertica is on-premise, I believe. And you can have unlimited scale of compute on Snowflake, which is not possible on Vertica. And also, since we separate the cloud and computing in Snowflake, we have we can split the costs of both of these, and you don't have to pay how it is combined always in case of Vertica or most other on-premise infrastructures.
Okay, thank you. There we've got another question from Lucas Mereyes. Here's the question. Do you think microservices architectures help on keeping the software code quality on high standards? Who's going to answer that?
Go on, let me have a go.
Go for it.
Oh, you swapped the question here, but go for it, Nick.
I'll go for it. Yeah.
Okay, here it is.
I'll be contentious. I think, choosing a microservices architect has no difference to code quality. What the difference to code quality is making sure your unit tests are there, making sure you've got code coverage, making sure you've got a good bug management process. And, to add, I really hate it when I go and see a team who've decided that every latest buzzword is what will make their code better. So they do wonderful stand-up meetings, and they've got a microservices architecture, and they're born in the cloud, and they're all in, and they have no unit tests and no documentation. And in fact, I was working with a team recently where somebody found a defect in the code we were working through, and I said, well, just raise a bug for me. And she said, oh, I'm not allowed to do that. I have to get my manager to raise bugs. And that's a sign. If you see that, that's a sign that there's probably going to be some product quality issues coming up. So microservices architecture certainly helps if you use it to compartmentalize your code and you write good unit tests and you can break things up. But in and of itself, it's not something that delivers high code quality. There's the other metrics that do that. Or somebody will say I'm wrong, but I think I got that one.
Okay. Where can I find this? So let me still keep this question active then, and I would probably ask Carola to answer as well, because I can see your emotional reaction. Go for it.
Well, for me, microservices is an idea to help the organization. Actually, it's it's for people. It's to have, the idea is to be able to have small teams that can work on their own, quickly deploy something. And this is when you need microservices from my point of view. And the other reason is when you have to scale, of course. If you are Amazon and you need the search algorithm like millions of times in a second, well, then you have to scale, and you need some deployable that is just doing that, and you can have it several times. But in the end, this cutting a monolith into pieces, for me, I reduce complexity and I have small teams that work on bits and pieces. But it's so difficult to do it, and in the end, it has. I'm absolutely with Nick. It has nothing to do with code quality. It's for the organization. This is the point. But thank you for the question, Lucas, because of course these questions come up a lot.
That's true. Sanjay, is there anything that you would like to add to it?
Sure. So when you have multiple microservices connected together, and especially when it starts getting complex, when you keep calling one another, you have to be very careful about making sure that each of those services are able to scale if you have designed it for scaling. And as the other panelists were also suggesting, having a good test architecture is super important to make sure that when you change one piece in this puzzle, rest of the things do not break. So you need to have robust test structure, especially automated one would be the best way to go in such cases.
Thank you. Fair enough. Actually, I would like to even wrap this out. So we know that testing, and especially unit testing, but actually plenty of different other testing strategies are also work very well to maintain the code quality and the application health in general. We know the other thing is the documentation, right? We had today the speech about documentation. Could you please bring here each one of you to list probably one or a few top important documents that you consider the most important on the projects for your purpose? Who would like to go for it? Like, for example, would you rate BRD over technical requirements or something else? So there's plenty of different things. Which one would you focus on first of all?
Go, Sanjay.
Sure, thank you. So I would always document and go for the business requirements first, because they are the ones which are driving the project in the first place. So that is having good clarity on what is expected out of the project is super important. Next thing is the technical architecture. How do we define the technical deliveries out of these business requirements? So I would always go in this order.
Okay, thank you. The next one's Nick. You go.
Yes. So I'd probably add to that. So business requirements first, but making sure that is allowed to change as the business requirements change. Because the business requirements you had at the beginning are never the business requirements they thought they were or they have at the end. So that needs to live and breathe through the entire thing. I think some other things are, as an architect, you're responsible for documenting anything complex you come up with. So I worked on a project a year ago where we handcrafted a blockchain application. And all the complex things, like how am I going to do cryptography, how am I going to do peer-to-peer networking, all of those things needed to be documented for the developers to learn the technologies and understand them. And then the next thing on top of that is I try to get my devs to document their code in the code. So in the .NET world, you have XML code comments, which allow them, and I'm quite strict on that. So every class, every method, every property, every event is documented as if they were building an API for one of the major vendors. So you can produce that into documentation that other teams can use. It's so much better than just little / comments in the code, although that's useful. But describing what everything does at that level, not only can I use it as part of the product deliverable, but I can also use it to help other teams interface with what we're building. So I think those are critical too. And bugs. Document your bugs well. Those are important as well.
Yeah.
All right.
I could add some stuff if you want.
Sure.
For me, the most important thing is to document your architecture decision. It's a bit what Nick said, just from a different angle. You know, what was the question, and why did you decide to build a blockchain thing yourself? You know, I mean, and this is this question and the answer and the different possibilities. Even, you know, this is I don't know if you have ever had this, but we built something, and then someone else came and said, "Why did you do it this way?" And I remembered, oh no. I had all the arguments, but it's like 3 months ago, and now they are all gone, and I have to dig them out again, and it's frustrating, you know. And if you write this down, this helps so much, so the other people to understand what's going on. And the other thing I would always ask teams to document, and it's sort of a bit related to what Nick said too, is the patterns that they use. This is something which is so helpful, and so there are not many teams who are doing this, but for me the language of patterns that the people are using, it's like a treasure. You know, you should say, well, what is the service, what does he do, what are the rules about calling other classes. All this should be documented. With that, you help the next generation of programmers a lot, from my point of view.
Thank you so much. This is more than fair. So let's summarize it. So we would like to have BRD because with the BRD, we always can answer actually the question, why we are doing this, why we are building this, why we are including this kind of functionality or not, why we are seeking for this, maybe even sometimes brand new technology, why. Then there is the architecture and the architecture in general, like the basic that everyone has to just have it. Then document any complex solutions, because times going, times changing, and we just can forget what is there inside under the hood. As well as the code, as well as unique technologies, especially unique technologies, because they will be quite hard to reverse engineer them. Code comments, no brainer at all. This is just it has to be out of the box rule for just writing the code. It should be actually one of the basic DOD for even passing code review. Then the decision log, which actually has to reply first of all to the question, why did you take this decision at this moment? Because there's plenty of constraints and conditions that be influence on your choice. Yeah. But times changing, and probably those conditions are not they don't have any influence anymore. They have been changed. So, and patterns the team is using, as well as some best practices, known issues, or just solutions that they use here. All right, that was a good and fruitful conversation. We've got one more question, and again from Lucas Reyes. Question is, what's your opinion on TDD taking place on the same metrics? I'm not sure I can properly understand this question. Could you please just, Lucas, could you please just clarify it in the comments? However, we can open a little bit the topic of TDD as well. Like we already said that test coverage and especially unit tests are crucial. I would suggest that in the modern world, when we have plenty of microservices, plenty of different technologies, clouds, and so on, our pieces of our functionality can communicate to the other ones and completely other service. So unit tests has to be something really essential from my point of view. What would you say here? Can you please raise 1, 2, 3 fingers to book your order in the queue? Who would like to go first? Then second, brilliant. Nick would like to go second. It works that way. So let's go. Third.
I can start.
Go for it.
I mean, in an ideal world, I would always do test-driven development. So I would write the test first, and then I would program the class, of course. And well, for me, it's often like this. When I start to program, I actually start to program some classes to get a bit into the feeling of this domain. But very quickly, I mean, after 1 hour, I start to program the tests to help me to stay stable with the thing. But if the whole thing gets bigger and bigger, I start to write the tests before, because doing test-driven development is so good in getting the interface of a class right, getting it done in a way that it should be used later on. So I'm really a fan of test-driven development, but I wouldn't. I mean, my point is, it's not a dogmatic thing. Do it as much as you can. But my God, I mean, this is like pair programming. We are doing a lot of pair programming in our company, but if there's someone who doesn't like it, okay, just program on your own. And we do something like what Nick told us before with somebody looking later on onto the result and having a review. Well, this works as well, So there's no dogma here. Okay, now Nick.
Thank you.
Yes, I totally agree with the no dogma, and it's fascinating when you go into teams who've swallowed the Kool-Aid, so to speak, and everything has to be built with a test first, and you go, well, actually, sometimes you can't do that, and sometimes you really shouldn't, because some of your tests are testing a single class that gives an okay result and has no logic in it. Why do I build a test for that? That's not exercising anything of any use whatsoever. So it's being pragmatic and reasonable and grown up. And all of these tools, all of these concepts, all of these frameworks are tools in your toolkit to help you get better. They're not holy scripture on how we should write software, and we need to treat them as tools. But TDD absolutely can help you improve quality. As Carola says, it helps. I prototype that way. Absolutely, because it helps me define what my classes look like, what my structures look like, what my interfaces look like, how the thing works, and I trip over all the mistakes I'm making on the way through before I actually give frameworks out to devs. And I like to give them, fully functional classes and say, now do proper code in there, please. So that's certainly one of the things I do there. So it does help, but also we pick up a lot of projects like the one I was talking about that had no tests in it at all. So you then have to reverse engineer your testing the way through, and sometimes I find quite often, and Carola, your slide which showed going back and rewriting the thing, so many times I go, it's such a big investment in code, and you get 6 months down and you go, I should have just rewritten it. I'd have been 800 times faster.
Yeah.
Okay, fair enough. Go into Sanjay.
Yeah. So as Nick was mentioning, it is very challenging to go back and start documenting the code or start writing the test cases there. If we get started very early on, that's the ideal situation. But in some cases, in some projects, you just don't have that freedom to really implement anything. You just have to get started with something. So in such cases, we just get started. But then at some point of time where you start looking at the quality of the code or output of that, you should always invest some time to start writing the code to make sure that it is able to track all the issues. Even if it is just the data that is flowing through, you can still write the test cases to make sure that it is able to match the quality requirements by writing the test-driven modules in between before it can get pushed into next phases.
Okay, thanks everyone. So summarizing just in general what it means. So TDD is a powerful tool, really powerful tool, to get your code ready, to make your project better, to control the quality of your code. However, as any other tool, it has its purpose. So never put TDD on front just for the sake of it. It just doesn't make any sense. You have to always know why you're doing that. If it's a different test, if it's any kind of automated test, or this is a stress test, end-to-end test, like sanity smoke, whatever else, it has to have its own purpose and appropriate time, as well as if we are using some other things, some other methodologies, for example, pair programming, or like daily commits, or for example, we would follow a way when we just build some functionality and then we rework it or we review it and refactor it in just a few months, where if there's a task causing some bugs, we just may completely rework it instead of fixing, just because implementation a different way can work much better. So there's plenty of different approaches. Pick the one that fits you better, but please be ensured that there are enough tests to show that your piece of functionality is at least stable and it provides the same result and outputs as it was doing that before. Because if it changed in a big system, especially in a microservice system, it can take really a long time before you discover it. Okay, we've got the last question and probably the last few minutes before our next section goes. So the question is, just a second, please. So this is again coming from Jose Pineda. Can Snowflake be used in an on-premise solution? If not, what could be a good cloud-native alternative?
Okay, so can Snowflake be used as an on-premise solution? You cannot put that onto on-premise. It is native cloud. It is going to stay on the cloud only, but you can only connect from all your on-premise infrastructure to Snowflake, but you cannot bring it to your local. So there is one thing you could do if you have a VPC, virtual private network, where let's say either in Azure, AWS, whatever infrastructure you have, you can create, you can request Snowflake instance or infrastructure to be within your VPC. But beyond that, you don't have any other way to, be closer to Snowflake. It's just on the cloud. Alternate cloud native alternates its competitors, you can call them, is Microsoft's Azure Synapse, and What other tools are closer to Google's BigQuery is another one, but they don't have a similar functionality. You can call them as closer to a Snowflake, but that's the closest one you will find.
Okay, thanks. I know that there is another, maybe not that much competitor, but anyway, a tool that is trying to do that, so-called cloud native, Redshift, if I remember correctly. So
Yeah,
it has some similar functionalities and options similar to Snowflake. However, well, that one I guess can be can be on premises because it anyway requires a separate cluster. But it's a little bit, it works in a little bit different way. All right, we've got today a really interesting Q&A panel. It was amazing to see how you're just throwing that ball and adding some more questions or bringing some more insights. The best way was to see how you answered the same question, but each one from a very, very specific point of view, which makes it quite recognizable. I would love to talk to you on the other conferences as well. However, now our time is going over, and say a few words before we're going.
Well, thank you very much. It was a big pleasure to do the same speech in different time zones. I'm unhappy that the Chinese people didn't get anything this time, but we will see next time. Thank you.
Thanks.
Yeah, it was a pleasure talking to you all. Thank you.
Yeah, thanks, Charlie. It's been a really good conference. It's lovely to see so many people thinking about looking at the architecture side rather than dev or DevOps or all the popular stuff. So a conference, and it's been fascinating being on a panel with people way smarter than me. So I really appreciate it. Thanks, guys.
Thank you.
Thank you too. Okay, see you very soon. Bye-bye.
Bye. Bye-bye.
Thank you, guys. Bye.
Okay, we are back to the Worldwide Software Architecture Summit. There's going to be a very, very quick break now. Oh, we are running out of time, so there's going to be no break anymore. However, I would like to remind you that we would love to see you among us at the React.js Case Study Festival on March 16-17. So the case is that there's going to be just 2 amazing days in 14 hours in 2 time zones to learn battle-proven React.js case studies of top companies such as AWS, Facebook, the origin of it, and Code Academy, Product Hunt, and the other ones. You'll learn how to make your front end accessible to everyone. You'll know about hooks and best testing practices, and much, 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 much more. You will have time to register. You had some time to register during happy hour to get a ticket for $30. So here it is. Let me quickly show it. Here we are with this. Here we are with this URL. And now we would move to the next section. There was no possibility for the following 2 speakers to take a live presence here, and we have their recordings. So the first one is a software developer from Germany. The topic is using AWS and Google Cloud in a cost-efficient way. This is called, this is, the speaker is Alexander Kotin, and the topic is about how to find out the best ways to use tools and some configurations in both big clouds like AWS and Google Cloud, how to compare that and all the stuff. And the speaker has founded his own software company in 2012, then focused on cloud architectures and cross-platform applications. As an AWS Solution Architect Professional certification since 2019, developed and maintained cloud backend with millions of sessions every month. So just a second. We are introducing, ladies and gentlemen, Alexander Kotin. Just a second, I'm gonna bring his video recording to this screen.
Hi, and welcome here at the Cloud Architect Case Study Festival. My name is Alexander Kutik, and I will give you a short presentation about how to scale on AWS and Google Cloud in a cost-efficient way. So why or how is it coming that I have this kind of presentation here? So I browsed a lot through different Medium articles and blog posts through the last months. And I saw a lot of posts like, well, Google Cloud, Firebase, AWS, it's all very cheap at the beginning, but when you start scaling, it's getting really expensive. And every time I read one of those articles, I was like, well, no, we did that. And it basically is a lot cheaper than if we had done it on our own way. So I wanted to just show you guys how we do it and how you all can scale in a very cost-efficient way. So I want to do this talk on a real-world example. So this basically is one application we have right now, which is in this kind of scaling phase right now. It's a sport and fitness app, and it's scaled from, I think, 1,000 to 60,000 monthly active users, and it's still in this growing phase. So we hope for a lot more users. We have 250,000 video plays every month at the moment, but again, it's growing very rapidly. So these are the current numbers, but they increased a lot against last month. For example, I think we grow around 150 to 200% every month. So we have 350K trainings completed every month. And at the moment we have, or the last month we had 1.8 million app opens. Basically, we have a very high availability, as I will tell you in detail later. We are on Google Cloud. Basically, I think we hadn't any outages till now, but I stated the availability with 99.9999% here. An interesting thing is our all-in backend costs are below 100 euro a month. Basically, last month we had, I think, 40 euros, and this month it will be around 80 euros. So basically, yeah, the costs increase, but they increase very, very slow. So I will show you in detail how we are doing this. So to show you what we do, I want to kind of simplify the example. And basically, this is what our application does. So we have users and we have exercise videos. And we provide the users these exercise videos, and they are combined to workouts. And the users can do the workouts, watch the exercise videos, and do the workouts. In the real world, the application is quite more complex, but for our case here, this should work fine. Before we start with the details, let me just introduce myself very briefly. My name is Alexander Kuttig. I founded my own software company back in 2012. I'm a solution architect, or I would call myself a solution architect since 2014, because I do application architecture since then. Basically, I'm working a lot with Google Cloud and AWS, not that much with Azure or other providers. Yes, really since 2016, I played around a bit before, but my first bigger architectures I built around 2016. I'm certified for AWS, Solution Architect Professional, and I try to write regularly on my Medium blog. So if you'd like to, you can follow me there. As I said, I founded my own company where I'm still working. It's called Horizon Alpha. We're based in Munich, in Germany. We are around 25 people. We hired some recently, so I think we're 28 now. Our main focus is app development, but always with cloud-based backends. We recently did also some cloud consulting, cloud architecture, because we have a lot of experience with scaling backends or scaling cloud applications based on AWS, Google Cloud, and MS Azure. Let's come back to our application or our details. So what we are doing when we plan a scalable application is we have basically four steps we think about. First one is we have to analyze our requirements. So what does our application do, and which parts of our application will scale in which scenarios? Second one is we have to choose the right services. So the cloud providers have a lot of different services. So we have to know which services do fit for our application and for our requirements. Then we have to create our application architecture. Which services do we combine in which way, and which languages do we use, and how does the general application architecture look like? And we have to keep in mind how to scale on that application architecture. So I will tell you in detail later. Last thing, and I think it's basically, well, maybe not the most, but it is very important, is database design. So if you have the right database design, you can really save a lot of money. So when you design your database, you should always ask yourself, how will this solution scale? And is it the right choice for my project? So let's start with the first one. So I try to build or to ask some questions for every one of these four steps. So basically, these are the questions you could ask yourself when building such a scalable application. So when we analyze requirements, we simply imagine the best case scenario. So what would be for us the best case scenario which could potentially happen? Then on the next step, we try to identify the metrics which will scale in this scenario. And then we try to think about what would this scaling scenario mean for all parts of our application. So I try to make an example. Basically, these are the scaling metrics for our application, for our simplified application. So we have exercise videos, as you can see here. And basically, even in the best case scenario, so we do we look at different scenarios, so best case, worst case, and we call it normal case. Even in the best case, the number of videos we have, number of exercise videos, won't change that much because every user will see quite the same videos. So we have around 100 exercises at the beginning, and even in the best case scenario, when the app really is used a lot, we would have around 350 videos in the best case, because exercises are limited. So we can't make a million exercise videos because there aren't a million exercises. On the other hand, we have the users, and users are really growing and a rapidly growing number in the scaling scenarios. So basically, we're around T4 at the moment. So we have, this is daily active users. So we have 25,000 daily active users at the moment. And we are quite on track with the best case calculation at the moment. And the users will grow very rapidly because the application is kind of viral at the moment. And the more users we have, the more users will get invited. And it worked from T3 to T4. And currently we're on track to T5. So this users metric is scaling very rapidly. So we have to keep that in mind when making our application design. Then there is traffic of the exercise videos. And basically, when we have 100 exercise videos and a lot of users, the users will download these exercise videos, which means the exercise videos will scale more like the traffic of the exercise videos will scale more like users than like the storage of the exercise videos. And basically it will scale more rapidly than users do, because when we have more exercise videos and we have more users, there is more traffic because more users download more exercise videos. So when we look at our simplified example, we see the storage of our exercise videos is not a problem. The users are basically a problem for us. We have to store them, we have to store the information, and this part of the application will grow very rapidly. And also, this is the traffic of the exercise videos to the users, to the end users. This also grows very rapidly, the number of traffic gigabyte. So now that we know which parts of our application has to scale, we have to look at the services the cloud providers offer us. So basically, here we have to ask us some questions again. First one is, what services are available for my requirements? So basically, which services do the cloud providers give me, which technically can do things I want to do? And you will see there are really a lot of services which basically can do the same things. Second one is, which services produce which costs in my scaling scenarios? So we have to look at every service and every service combination we have, we potentially have, and think about what costs do these services produce when my application is scaling. And the third question, and this is also very important, is you have to ask yourself, how much do you want to do yourself? Because there are a lot of different services which basically do the same, but with another level of management by the cloud providers. So for example, you could use EC2 instances where you have to think about scaling yourself and things like that. Or you could use Lambda functions where you just put your code, and AWS does everything like scaling and things like that. So that's also an important question, because when you look at the cost factors you have in the cloud or by the cloud providers, basically there are three things: storage, traffic, and compute. These three things produce costs for the cloud providers, so they make you pay on these things. But also, and this is what I stated here at the bottom of the page, the more the service is managed, the more expensive it is. So basically, when you have Lambda functions and you have EC2 instances, which you manage the best possible way, the EC2 instances will be far cheaper than the Lambda functions, because you have to do a lot more things by yourself, and AWS has to do less. But basically, in the most cases, AWS is a lot better in managing these applications and these things. So in most cases, I would say that AWS is more effective in managing and things like that, makes the more managed service cheaper than the less managed service in most cases, I would say. Yeah. So back to our application. So we had to choose the correct services for our scenario. So what you can see here is a lot of different services we analyzed. And yeah, well, on the right-hand side, you see the AWS symbols. On the left-hand side, you see the Google Cloud symbols, and it's just some of them. So you really have a lot of services to pick from. And well, basically, the orange ones are compute services, and the blue ones here are database services. So even for single tasks, you have a lot of different options to choose from. Basically, for us, we wanted to have kind of the highest level of managed services. So we just wanted to put up our code. We just wanted to put up our database. We didn't want to care about scaling or things like that. So this reduced the services to pick from a lot. But as you can see, there are still kind of a lot of services. We ended up with a Google Cloud based solution because basically, I don't know if you know it, but there's this suite called Firebase, where you have kind of database, authentication, cloud functions, cloud storage. So you have all what you need for your application. And it's integrated very well, and it gives you some advantages. And it used to be another company, but it was acquired by Google, I think, back in 2017. And Google integrated this Firebase suite into the Google Cloud platform very well. So you, on the one hand, have this managed suite, and on the other hand, you can use all the Google services in combination. And you can also go outside the Google environment and use AWS for storing or things like that. We did that in other projects, but in this case, we just went full Google stack. Yeah, basically, the choice was because it was this managed services, and it was very easy for us to start with, and it made it possible to have very fast development speed. So now that we have our services, we have to think about creating our application architecture. And that's the last three steps here aren't one after another. You have to think about all of the three steps at the same time, because creating your application architecture has something to do with the correct services. Designing your database has something to do with the correct services. So basically these three steps you have to think at once. And when you create your application architecture, this is one step where you can really save a lot of money, because in a lot of application architectures, you have things you don't need to have. And because of that, I would urge you to ask yourself these questions when creating your application architecture. And the first one is, what should your data flow be? Where should your data go through your application? Second one is, when do you need to load which data? You have to think about in your application not to load data you don't need to load. Third step is, what do you really need? I will talk about this in more detail later, because and sometimes you could just not have some things in your application architecture, which means you don't have to pay for it if you don't use it. The last one, and I think that could be another talk here, it's how do you ensure security? This should also be on your list, even if it's not to save money. It will basically cost you money, but you have to do it, right? So let's come to data flow, and this is quite interesting because this is our application, and this data flow lets us save a lot of money, because we have the option to go directly from the application to the cloud storage and the Firestore. This is possible because the cloud storage and the Firestore is connected somehow connected to the Firebase authentication system. And basically we get kind of a token from the authentication system if we log in. And this token makes it possible to access specific locations in the Firestore or the cloud storage. So what we did was we didn't use any real backend here because we don't want it to produce this costs when just read data. So we ensure that every user can just read data which he or she should have access to by things which are called Firebase rules, which basically connect the ID and the auth system, the user ID and the auth system. And that basically means we don't have to have any kind of backend here, which means we don't pay for the backend when we just do read operations. We decided to have this kind of backend with Cloud Functions here for write operations, because write operations basically can harm a lot more than read operations. And when having things not in a web client but in a native app, you can't change things very rapidly. So you have this application on hundreds of thousands of user devices, and it takes quite a long time until every one of these devices is updated with the new version. So we said, okay, we want to have more control about the write operations, and that's why we decided to put a backend here. But the interesting part is we just did it for write operations because we said, okay, if anything is broken with our read operations, the baddest thing which potentially could happen is that the application here won't work. and the user has to update the application. But when a user writes some bad data, we want to be in control to fix these bugs as fast as possible. But only for not having the backend for the read operations, it saves a lot of money. Because read operations, we have a lot more read operations than write operations. Second thing here is when to load data and how to use caching. I want to show you on our exercise video traffic, because in the first implementation of our application, we had no caching at all. So we just were live streaming or streaming these videos. So every time a user wanted to watch a video or did a workout, the application just streamed the video from our storage, and that would create a lot of traffic. Second idea then was to store the videos completely on the user device, which basically was kind of caching. So we just were downloading all the videos when the user downloads the application. Then we start a background task, and this background task downloads all the videos and stores it on the user device. Which basically saved us a lot of traffic, but it wasn't good enough, because not every user wants to look at every video. So what we then did was we had some store on demand options, where we just gave the user an image of the video and gave him or her a button which could be pressed, and which then starts the video download. The user had to wait 1 or 2 seconds, then the video was playing. And basically this wasn't that bad for the user, because he saved a lot of storage on the device. And yeah, it was quite okay from the usability point of view. And it again saved us a lot of traffic, because now the users only download the videos they want to look at, and they only download it once, and then it is stored on the device. And basically, this is just one example how some strategies of caching and thinking about when to load data can really have an impact in things like traffic. And that, again, can save you a lot of money, because you have to pay for every gigabyte in traffic. And yeah, that are the things you have to look at when designing your application architecture. Last thing I want to talk about, and well, maybe not the most important thing, but a very important thing, is database design. Basically, again, you have to look at your requirements, and you have to think about what information do you have to write a lot, what information do you have to read a lot, how is it compared to another? So do you have to write more? Do you have to read more? In our case, we had to read really a lot of data, and we just have to write some data. So we do read a lot more than write data. And last thing is, you have to think about how is the information connected. So in our case, basically most of the time the user is fetching his own information. The user is fetching the workouts. The user is fetching the exercise videos. But there's no really hard connected data. So in our case, we really benefited from a NoSQL database. And because database design is a really big topic on its own, I just want to give you some tips here. First one is, don't be afraid to use NoSQL, NoSQL database solutions. We really had good experiences with NoSQL database solutions, because you can optimize them for reading data very good. So when we read some data out of our NoSQL database, we just make one call and say, give me that document, and our database is very, very highly optimized for reading data. And so we don't have to do any manipulation of the data on the server side. We just store the data as we need it in our application. So we just go to the database, say, give me that document, and I have exactly the data which I need, which again saves us a lot of money because we don't have to pay for any compute power. We don't have to pay for any complex calculations. We just have to pay for one read. That leads me to my next tip. Don't be afraid to duplicate data when using a NoSQL database solution. So again, we highly optimize our database solution or our database for reads. So that means we have to write on different nodes in the database and to come to that state that we just have to read a single document for every of our calls. This basically means you have to ensure that the database stays consistent in your business logic. But again, we do reads a lot more than writes. So to run this business logic on writes is much cheaper for us than to run some kind of calculation or computation on every read. Last thing is, don't be afraid to use different database solutions. So when thinking about an application that should scale, you also have to think about the strengths and weaknesses of the database solutions. So it is totally fine to use different database solutions for different tasks. So in our case, we have the NoSQL database solution for the end users and for highly performant get information out there. So the user goes to the database and it just takes milliseconds to give him the data. On the other hand, we have to do some analytics about around this data. So we want to know, want to combine the data, we want to learn from the data, and that makes there are a lot more complicated queries which we have to do. And this is a lot easier using a MySQL database or a kind of data warehouse solution. So what we do is we kind of copy parts of our NoSQL database into another database solution. In our case, it's a MySQL database solution. And our analytics queries, which can take some time, we don't have to have the answer right now, right? We make an analytics query, we start the query, and it's totally fine if we get the result 1 or 2 minutes later because it's no end user related stuff. So we don't have to have a high scalable or high performance MySQL solution here. We just have to have any kind of MySQL solution which we can run these queries in. So that's why I say don't be afraid to use different database solutions for different scenarios. And basically, that's it for today from the database design topic. Again, think a lot of what tasks can be achieved with which solutions, and what costs would these different solutions produce for you. And again, when you go for a solution where you have a lot of end users, in my experience, NoSQL database solutions really are a great fit. So to wrap this up a little bit, I have another tip for you, and it is stay up to date with the services the cloud providers offer. All the things I mentioned, you can only do if you know which services are available and which cloud provider offers which service. And again, which service produces which costs in which scenario. So your main task when you think about cost efficiency is to always have an idea which services are out there, which services fit for your need, and which services produce which costs for which metrics. And basically, if you have a very good understanding and a very good idea of these things, it will be very easy for you to build a cost-efficient scaling application, because it's kind of the thing you do automatically. Well, that's it from my side. I think you can use these questions I put into the slides just as a kind of reminder which things you should look at when building your scalable application. Thanks for listening. I hope it was kind of helpful for you. And if you have any questions, you can just contact me via email or via my LinkedIn. And again, if you'd like to, you can follow me on Medium. Thanks again, and have a nice evening.
Thanks to Alexander Kotin. This is a CEO, founder, developer at Horizon Alpha in Germany, and it was a topic dedicated to using AWS and Google Cloud in a cost-efficient way. So now we all know much better, and to be honest, I was also excited about how much we actually can save. I used to work with clouds as well, and I know that they can be sometimes really cost effective. However, this use cases discovered a lot of really exciting insights, and I'm gonna think about how to use this, how to apply this knowledge in my work. Now we are moving to the next section. We are still inside the non-functional requirements block, and our next speaker is a solutions architect from a company called DAZN from UK. Ivan Rigoni is an Italian from the Alps, working in IT since like 2000. Worked his knowledge up from the dawn of internet, e-commerce, IoT, and now to sports streaming, landing him in London in 2007, where he lives since. And when he's not working, he's got long runs with his Labrador and helping his daughter with her coding projects. So the topic is 1 million requests in just 10 minutes. Sounds quite impressive, right? And you know that building a system with plenty of requests, a really reliable system that can operate with all those requests and all that stuff is just quite really complex. So we would like to hear now how to deal with it, right? Let's launch it and see where it goes.
Mentioned, I'm Ivan Rigoni, solutions architect at DAZN, and I'm going to talk to you about 1 million requests in 10 minutes. A topic that sounds exciting, isn't it? So if you're interested, then follow me. DAZN is a sports streaming service that lets fans watch their favorite sport over the internet, their way, live or later, and at a fixed price. And we operate in over 200 countries. The title of today's presentation comes from an interview question that I used to ask to candidates for the position of principal engineer or solutions architect. That is only the start of the question. Let me introduce you to the full question. So the full question context is the following. So you have a monolith piece of software that runs both your backend and the front end of your application, of your system. This monolith is interfaced to third-party platforms to take payments and to create subscription by means of transactional calls. So you have synchronous calls to these third parties to perform something like taking a payment and creating a subscription, as mentioned. You have a non-functional requirement stating that users are signing up at a rate of 1600 per second with peaks of 3000. But more important is a business requirement that says that DAZN's core business are live sport events. So we have to ensure that our users can access our systems seamlessly and can watch the live event now, not being bothered by sign-up procedure. The implications of all of that are, first, for the first point is that with a monolith, you can only scale horizontally to add capacity, so adding instances of your service. The fact that the calls are transactional, so point number 2, means that the slowest system in the chain is the one that determines the overall speed of your system. That is, if your monolith can support 3,000, 4,000 transactions per second, but the payment platform only 1,000 and the subscription platform only 20 transactions per second, the overall speed of your system would be 20 transactions per second maximum. This, of course, clashes with your non-functional requirements stating that you have to support 1,600 sign-ups per second with peaks of 3,000. You see that there's something not working here. And the last one states that whatever the non-video failure of your system, the priority is to ensure that the users can enjoy the live content they are signing up for now, straight away. Visually, I can illustrate that with the sequence diagram you see on the right-hand side of this slide, where a user is approaching the zone and signing up for. So in the first point, they submit their details, name, surname, password, whatever. And the sign-up endpoints responds requesting now the payment details. Once the user has filled in the form, this is posted to the subscribe endpoint, and the subscribe endpoint makes a call to the third-party platform, the payment platform, to take the payment from the card. Once this is done successfully, we have all the elements to create a subscription. So we make another call to the subscription platform, and we create the subscription. All done, great. So we can issue a token to the user, and the token can authorize the user to access our platform and play back the live content. Now, these approach has pros and cons. So the pros are the scaling, as I mentioned earlier, very easy, add instances and you scale up. System interactions are straightforward, everything is linear, sequential, you have no race conditions, so no complications in the interactions. However, let's say, from the efficiency perspective, you can't scale up only what is under stress in your system. So you have to scale up everything, possibly ending up in a waste of resources and high cost. From a security perspective, you load the entire code base in memory. It's a single monolith, right? So that means that all the code can access all the resources, database handles, encryption keys. So whatever you need, basically, to access third-party systems, and is shared by the entire code base. That means that if anybody can compromise your monolith, everything is compromised. So from the velocity perspective, the fact that you have a monolith with millions of lines of code, every time you make a change, you have to regression test the entire system. So let's say to make the release more efficient, you tend to group more changes into the single release, making them risky and causing also painful rollbacks if anything goes wrong, because if something in your release package is incorrect, you have to roll back everything, not only the change that caused the failure. From a maintenance perspective, you have a single code base, so you are most of the time restricted to a single technology and single language, just thus hampering innovation, and it's a constraint that many engineers don't want. And again, from a performance perspective, if one endpoint is under stress, so is your entire monolith. What am I expecting from, let's say, a candidate response? One option could be the following that I'm illustrating now is actually the more common. So the first thing you can do to your system is replacing synchronous call with asynchronous ones and queues at the integration points. This is to decouple the speed of the caller from the speed of the external system. That doesn't come for free, I'm afraid, because you have to introduce eventual consistency anywhere possible. So that is the result of the CAP theorem. This is not a presentation, I'm afraid, about the CAP theorem. I'm supplying a link in the slide if you want to have a look at what it means. But basically here we are compromising on availability. Therefore, we need to compromise also on consistency and aim for eventual consistency rather than continuous consistency. Third thing we can do is breaking the monolith. Of course, microservices, first thing that comes to mind. Fourth thing, given we introduced microservices, or at least we've broken down the monolith in multiple modules, the system becomes more complex, failures become more frequent, there is network traffic between the services that can cause additional failures, so you have to design for failure. So let's have a look. Point number one, how we can implement it. 1 and 2, actually, applying eventual consistency. So we can interpose between our monolith and the payment platform a payment facade that decouples the monolith communication with the external system, and replace the take payment call with a pre-authorization call. I will tell you in a bit the difference. We can also interpose between the backend monolith and the subscription platform a subscription queue. So for every subscription we just push a message to the queue. So how does it work? Let's switch to the right-hand side of the diagram, which is the sequence diagram. Once the user submits the card details, now we don't take the payment. We create a pre-authorization call that validates the payment details and ensures that the user has funds in their card, but we do it via the payment facade. So the payment endpoint calls the payment facade. The facade has all the details to call the third-party platform, retrieves success or failure. Let's assume it's a success. Once this is done, we can push a notification to the subscription queue saying, yay, the user has signed up, they have submitted the details and they're valid, so we are 80–90% confident that everything is correct, so we can also create the subscription. So now we can issue the token to the user so that they can actually play back the content. In the meanwhile, behind the scenes, whilst the user is enjoying the live sport event, we pick up a message from a notification from the subscription queue. We attempt to take the payment from the user via the payment platform. If this is successful, then we create the subscription, taking all the time we need to do it. If this goes wrong, then we revoke the user's token and we say, sorry, you can't access the platform any longer. Something went wrong, your payment details were wrong, fraudulent, whatever happened. What are the benefits of this arrangement? So first one, the monolith becomes independent from the third-party platform performance, so we can go faster. Performance, we can optimistically accept a sign-up. That's what I illustrated, the change in arrangement. So first, we do a pre-authorization, just validate the payment details. We don't bother with the long transaction to take the payment and create the subscription. Maintainability, facades, they are nice because they allow to replace the third-party platform easily, shielding the monolith from the changes. And then they also established a single entry and exit point for all our network traffic so that we can better monitor what is happening, improving observability, really important. Security-wise, only now the facades have the encryption key to access the third-party platform, certificates, whatever it is. So this kind of information is not shared across the monolith. If the monolith is compromised, our facade can be safe. And now our monolith can go much faster, of course, because it doesn't have to wait for the subscription platform to create the subscription. Users are happier, of course. Now we want to break down the monolith. However, before doing that, we want to remember the Conway law, which states, reading literally, organizations which designs systems are constrained to produce designs which are copies of the communication structures of this organization. This means that the interfaces in your system will be copies of the interfaces within your organization, across your teams. This can be a bad thing if your organization is not structured correctly. So the best thing to do is invert in the Conway law and use it to your advantage. So what you can do is literally design your organization the way you want your system to be designed. What did we do at DAZN? So we created a developer experience unit, organizational unit, which is in charge of supplying tools like command line tools, like CI/CD pipelines and deployment dashboard, relieving the engineers from this burden of maintenance of the tools. We designed the boundaries of our system, how it was supposed to be realized architecturally. So domain-driven design applied to our software, so divided our software into browsing experience, playback, payment, subscription, living room experience, and so on. Once we've done that, we apply the inverse Conway law. So we create a team for each one of these organizational boundaries. And finally, we've been agile in applying agile. We left to the engineering teams to decide how they wanted to operate. Do they want to use Kanban? Do you want to use Scrum? Both, whatever. Our agile coaches are there to help. So now we have our organization ready to, let's say, start the work on microservices. This is what happens basically in a nutshell. You take your backend monolith and divide it into several modules or microservices, as you like. And the front end also can be split into multiple responsibility areas, the micro front ends, the same way you would deploy microservices. So benefits of this approach of splitting down in microservices. So resiliency and availability. You have massively reduced blast radius if one service fails. You don't have everything taken down by a single service if you design, of course, things correctly. That's the caveat. And then you can also apply different service level objectives for different types of service. Performance-wise, you have granularity of scaling, so you can scale up to multiple, to dozens of instances of your sign-up endpoint, which is supposed to accept multiple sign-ups, but maybe your retrieve password or forget password endpoint doesn't have that much traffic, so it doesn't need to be scaled up that much. Maybe 2-3 instances are enough. So that gives you more efficient use of resources and money as well. Velocity-wise, you can release multiple times a day for each single service or micro front end, and that paves the way to perform more testing, more user testing, changing a little bit, I don't know, the browsing experience and see how users react, expose some other users to a different way of playback. So this is multivariate testing. The fact that you can deploy multiple times a day enable these kind of things, which has a lot of benefit. And from a maintainability perspective, each team can decide what language and technologies to use among approved ones. Of course, I mentioned developer experience unit is in charge of providing the tooling. So each language carries tooling with itself, and we cannot provide tooling for everything. But of course, we can supply a wider range of tools given that each service can be implemented with different technologies. Security-wise, you have maximum granularity of security policy on a service by service basis, on a micro front-end by micro front-end basis. And you can embed, having smaller code to handle, you can embed security in your software development life cycle. It's not that easy, though. There is a big decision to take. Do we aim for feature parity first? So create our new platform in microservices and micro front-end, re-implementing the same interfaces, or do we apply greenfield development? So redesign the system from scratch, forgetting entirely about what we had before. So let's see what the two approaches mean. So if you go for greenfield, you create an entire new system in parallel to the old one, to the legacy development environment, and you evolve both until the new one is ready and you perform the switchover. This might take a while. With the feature parity first, what you do is taking a small portion of your legacy environment, such example again, the sign-up endpoint, and you replace it with new software, only that endpoint, and you start driving traffic to the new endpoint, switching off the old one, and you repeat the exercise for each of the endpoints until the legacy environment doesn't receive any traffic at all, and you can switch it off. This is called the Strangler pattern. It has some benefits, though, because you expose your software, your new software, early to production. At DAZN, we had an additional constraint posed by smart TV set-top boxes and similar mobiles. Alexander before mentioned also this issue that you have longer release cycles for, let's say, these kind of platforms. So you cannot change that frequently, the front end of your application. So we had actually to aim for feature parity first. So first, replace the backend, exposing the same interfaces as the old legacy environment, and then also evolve also the front end, because it takes longer to release and expose to users. The Strangler pattern I mentioned works this way. So you place proxy router between your legacy environment and the front end of your application. This allows you to route a portion of your traffic to the new software. Seeing how it reacts, if it works well, you add more and more traffic to the new software until it reaches 100%. In the meanwhile, you drain traffic from the legacy environment until it reaches 0%. You strangle the legacy environment. That's why it's called legacy. It's called the Strangler pattern. And then you eliminate the old environment. We also applied other patterns in order to evolve. One thing we chosen is a push-based approach rather than pull. So when you have millions of users accessing a REST endpoint, either it crashes if it doesn't support those numbers of users, or you are anyway exposed to unpredictable request patterns that is pretty inefficient if these, let's say, clients are polling repeatedly for information to have it quicker. So the best way to do is to serve them the information when these become available, so you are in full control of pushing the information to your customers. And this is what our PubB internal product does. It broadcasts messages to millions of clients via WebSockets. It is more efficient, smaller architecture, and can support millions of concurrent users. Another pattern we preferred to use was message-driven design. So the core of this pattern is pretty much having a loose coupling between producers of information and consumer of information. Producers don't know about consumers. They just push a message, and consumers can be multiple, and they know what to do with the information and how to proceed with that processing. This particular architecture you see on the screen is our external system event service that is in charge of receiving notification about your changes to your subscription and then processing it. As you know, when you handle a subscription through the mobile platform, Google Play, rather than Apple App Store, rather than Roku, you're not in control of the subscription. It happens, let's say, the user makes changes on those platforms. So what we can do is receive a notification from these platforms that the user want to change their subscription, upgrade, cancel, pause, whatever they want to do. We receive different messages for these from different platforms in different formats. Some serve you a real-time notification, other expose REST endpoint. What we do is unifying these messages and normalize in a single format, augment the message with additional information about the user, about the subscription, and then we route the message via, in this case, AWS Event Bridge to different endpoint, applying some rules. So if the message contains, let's say, a request for cancellation, then we route it to the cancellation endpoint. Otherwise, we route it elsewhere. So this is the approach we follow. All of I described and much more allowed us to acquire as many subscribers in our first 18 months of life as Netflix did in 5 years, which is a no mean feat. We learned a lot of lessons along the way, and I'll try to be quick, not to bore you, but there are a couple that are really important to know. First one, monoliths are fine in the right context. So if you start like DAZN did in 2016 as a startup with a handful of employees, you are faced with a big decision. Do we buy the software we need to prove that there is a market for OTT, live and catch-up sport events? Or do we build the software to create such a platform and support millions of users? There's a big difference. If you buy and go out on the market, you choose your the most suitable products, you stitch them together, and you create, let's say, an interaction of monoliths, if you like. And then you have, however, a quicker time to market because you can test your hypothesis. In this case, is that there is a demand for OTT live and catch-up sport events at a fixed monthly price. That was our business hypothesis. And we take early feedback from our users and build competitive advantage with the time saved. In the meantime, we recruit engineers for the scale-up phase and structure the company for it, and then we refactor and scale up. If you go for build instead, first you hire the engineers, which is a lengthy process. You design your overall system that will support tens of millions of users, but you might risk big. You might risk to build a system for tens of millions of users that might never materialize on your platform. Second lesson, architecture are not created, they emerge. So you have basically to agree and don't impose on architecture. If you create an architecture, an architecture which is created is promised by a date. It is created by the architect with no interaction with the expert or the areas, the engineers. Result in tension because the engineers, they want to have a say, of course, in how things are built, but they don't know the context because they haven't been told. So they don't know about, they don't know much about why some decisions are being taken. And the result, of course, is stress of the architect that has to do all the architectural work and talk to many people in order to get it done. And the product owner is in wait for the architecture to be completed before starting the development process. This is a waterfall process in many ways. Emerged architectures instead are the result of multiple discussions early in the process with the engineers, with all the stakeholders. Engineers participate to the decision process, contributing and raising questions, preparing different options from the one that the architect has thought about. So they foster diversity of opinion, enable better decision making, and allow for delegation on low-level design tasks, because now we have engineers that are aware of the bigger picture, are aware of decisions to be taken, so they can take on board some architectural work, low-level design, so that the solutions architect can focus on a sound, high-level solution and talking to the stakeholders, which is time-consuming, I'm telling you. And this is more, let's say, suitable to an agile architecture, an architecture that moves in time. 3, I'll skip over it, but be aware that you never have to start without an agreed MVP. So you have to test the hypothesis, your business hypothesis you go for. That's the most important thing to do when you approach a project. 4, requirements, really important. An architect never has to figure out requirements. Always ask the right questions to surface the requirements. And be patient. Finally, most importantly, document the key decisions with architecture decision records. There are documents that you store in a version system like Git or Confluence, because they can change over time. You have a status, a context of where the decision is taken, forces driving the decision, the options, the decision taken, and the rationale. Who devised this method is Michael Nygaard in 2011 in a blog post that I linked in this slide. And he's famous for his released book that I really recommend to read if you haven't yet. And this is DAZN, how it appears now. I have another couple of recommendations. Microfrontends, a book by Luca Mazzalira, if you want to know more about this topic. And the Lean Startup, really important because it talks about startups, MVP, testing the hypothesis, all stuff that an architect should, approach. Many thanks for listening to me.
Hey, welcome back to the Worldwide Software Architecture Summit powered by Pickel. We are really happy to organize these exciting events. We have a possibility to invite plenty of really interesting people, listen to their insights, get whatever it is useful for our career growth, and so on. So we've got this session probably ended by this moment. We've got one more speaker, which is Rohit Bhartavat, Resilient Cloud Architecture Design Patterns. However, there is some technical issues with connection at this moment. The good news is that Rohit has already performed his session once for European zone today. So the video recording will be available along with the entire track. The only thing is that we just cannot enable it right now. Also, one more interesting thing is that we are now announcing the winners of the prize that we've been announcing before. If you remember the tickets giveaway for questions, the condition was to send some questions in comments. Would it be via Pine Tool or YouTube comments? We've been tracking everyone who's been asking those. So at this, we've been asking actively questions and putting there the hashtag. So at this moment, we are almost ready to go and define the winners. So what we are doing is literally opening random.org. And let me do this quickly for you. What I'm gonna do is I will share my screen and I will input there a list of users. And then we will be just, so let me show you quickly how it's gonna be looking like. All right, so this is it. This is the random.org list. Here I've got a list. I've got a list of people along with their questions. So we've got quite a lot. Just let me copy and paste it. So here, right now, I'm gonna show you the people and their questions. You can see that most of them have been asking a few questions, which means that each person have their own line. We can see, for example, a few questions from Marek. It is right. Let me show you. We've got two questions from Marek Marchuk. We've got two questions from Claudia Postagnol. We've got two questions from Musa Vuli, and we've got 4 questions from Lucas Meireis, 2 questions from Jose Pineda. The other ones have been asking 1 question. So now I am entering there just the list of users without their questions. Here we are, ladies and gentlemen. Okay. It's gonna take me some time to remove all the redundant signs. Don't worry about that, so that I don't have any redundant lines. As you can see, here we are. Almost clean and tidy. When I push the button, there's gonna be 5 usernames on top, which enables also a possibility for a few people to be selected. So, or for one person to win a few tickets. Cleaning up the screen. Okay, it's gonna be a little bit exciting. Done. Again, Virgil Cherishes, Marek Marchuk, twice. Gurmeet Singh, Mohammad Kwanid, Vikas Pandi, Ray Kalkan, Ishwar Kumar, Patrick Kardas, Shem Maluf, Claudia Postagnol twice, Musa twice, Lucas Meireis 4 times, and Jose Pineda twice. The list is ready, so who's gonna win the tickets? Who's gonna win the tickets? 5, 4, 3, 2, 1. Randomize. Boom, we've got them. So let's see. The full list goes with Eray Kalkan, Mohammad Kwanid, Lucas Meireis, Marek Marchuk, and Lucas Meireis 1 more time. The full list will be saved, and those 5, I'm gonna just put them into the chat. You can see them in the comments on YouTube. Let me post it there. So here we are. These are the winners of this event. So they will gonna get tickets to our next events. Now, yay, let's congratulate them. That was really amazing. We always really starve for good questions, because questions create the knowledge, and you know that very well, right? That feeling when you go to a conference, you prepare a really nice material, and you're always curious, who is interested in that? Who's gonna ask some question? Is there anyone in that audience who has been impressed by this material so much, or found something useful or interesting? So there is this kind of connection, you know? All right. So I guess it's a really nice thing to just appreciate those who ask questions. And we saw that even the randomizer appreciated a little bit those who asked the questions the most. Now, I would like to remind you that we always have exciting news, and this time we have even more. So listen to that. What we've got. Gickel is moving to a new format. That's true. Starting from today, everyone can join Gickel educational platform to get access to the recordings of all of our amazing events, both past and upcoming. Also, we are starting new series of weekly episodes focused on different aspects of developers' growth. Here are some details on what benefits you well by joining our community. So we've got weekly online meetups with unique content from top speakers, videos from past and upcoming summits by Gickel, worldwide networking with a community of more than 60K of developers. Wow. Don't miss out an opportunity to receive our free trial today. And all attendees of the Worldwide Software Architecture Summit will receive 21 days of free access to the platform. Just go and test it, check it, try to review some videos and so on. Use this time in a good manner so that you get a real glance on what we propose. You can join us by using this link, and I'm gonna post it now to our YouTube comment section. Here we are. And there's gonna be a banner for it. Just a second. Take a closer look to the screen. Here we are. edugickel.uscreen.io. All right. I would like to announce that at this moment, this first day of Worldwide Software Architecture Summit is gonna be over. We are closing it for today. We are starting tomorrow, and there's a second day, and there's be more speakers, more amazing topics, conversations, interesting questions, answers, and many other things. For today, I would like to remind you that almost a year ago, Gickel started with first conference. Since that time, there were many of them. We've been talking about React, React Native, Flutter. We've been talking about different, like Angular and React. We've got Python and the other things, Java platforms. Right now we're talking about software architectures, and we are moving even forward to React and to deeper insights into it. There are different topics. There are different things. There is plenty of knowledge in this world. There are thousands of experts that are just waiting for the moment when they've got the audience, they've got the connection, and they've got the possibility to just say, look, here I am, here's my knowledge, here's my expertise, and there's you starving for this. Let's get and exchange it. IT community is growing over the years, and IT communities, first of all, produced amazing systems. You all know Linux and free Linux distributives that are growing up, you know, free contributions to like PHP platforms and so on. You know examples when just people from all over the world connected their knowledge, their expertise, and they created something exciting, something new and exciting, like free services and contributions. So let's invest our time, money, knowledge, and courage into evolving this solution more. We are here at Gickel to do that for you. Thanks, everyone, and have a nice day. Bye-bye.